各位现场的
Distinguished guests, ladies and gentlemen, good morning. Welcome to the 2022 AIoT Application Forum. I'm today's MC. In today's forum, we will talk about some important issues about smart manufacturing and Taiwan's digital resilience and digital upgrade. As we all know, the year 2022 is a year of challenge and uncertainties. For example, inflation and a rising interest rate and the global supply chains restructuring, all these challenges have posed great impact on Taiwan and the world as a whole. Over the past few years, based on our observation, the Taiwanese society has demonstrated great digital resilience. Over the past few years during the pandemic, we have seen a lot of efforts. For example, our efforts to introduce the industrial metaverse and also the deployment of AI and 5G. All these have been implemented in the factories and to optimize the production lines to achieve innovative business models and services. So throughout today, we will talk about all these critical issues. We have also invited important companies and experts to share with us their insights and observations. Without further ado, we would like to invite our speakers to come up to the stage. First, we would like to invite Ms. Amelia Day, Secretary General of the Bureau of Foreign Trade of Ministry of Economic Affairs, to give us her remarks. Please welcome her. Ms. Alina Lee, Executive Vice President of Taitra. Business leaders, our speakers and experts, also our participants on site and online and home and abroad. Ladies and gentlemen, good morning. First of all, I would like to extend my warm welcome to all of you for attending the AIoT Application Forum hosted by the Bureau of Foreign Trade of the MOEA. I would like to thank you for your participation. So speaking of the theme today, AIoT, over the past few years, because of the AI and 5G's rapid development, the applications of cloud and IoT are becoming more and more extensive. Also, due to the pandemic, our companies and manufacturers have accelerated digital transformation, introducing various cutting-edge technologies into the production lines so as to enhance productivity and efficiency and move towards smart manufacturing. The key technology to smart manufacturing is the use of IoT and AI for data analysis. All these are built upon solid electronics technology. Taiwan's electronics industry is internationally renowned. We not only have mature technologies, we also have complete clusters of upstream, midstream, and downstream industries. All these are Taiwan's advantages in a global electronic supply chain. I would like to share with you some numbers. According to our statistics from January to September this year, Taiwan's electrical and electronic industry exports mounted to $200 billion, up 18% over the same period of last year. Among them, exports of electronic parts amounted to 150 billion US dollars. All these have demonstrated that Taiwan is an important part in a global electronics industry. Since the government promoted the 5.5+2 Industrial Innovation Plan in 2016, promoting the IoT development has been a key area of the Asian Silicon Valley Plan. Also, under the 6 core strategic industries policy, it has integrated the IoT, AI, 5G, and ICT industries, hoping that by leveraging Taiwan's long established advantages in semiconductors and ICT, we can promote the digital transformation for Taiwan's industries through AIoT technology. Therefore, to help the manufacturers secure more opportunities for international cooperation and promote Taiwan as a core base in a global supply chain, the Ministry of Economic Affairs has continued to strengthen our supply chain cooperation with Europe and the US in key industrial areas and to deepen the industrial links. We also try to deepen our cooperation in the area of EV, 5G, and smart cities. So Taiwan tries to expand our applications of our ICT advantages to enhance our impact and competitiveness of Taiwan's industries in the world. So through conventions and also different channels, we try to assist our industry players to forge high-tech industry cooperation through various channels. We also try to cooperate with other countries in talent exchange and training, hoping that we can build stronger supply chain partnership with the world so that we can discover greater business opportunities for advanced technologies. So among them, the Taiwan International Trade Shows hosted by TAITRA provides a very good opportunity for us to get in touch with the most advanced technology. In today's forum, we have a series of activities. This is one of the events. We have invited experts in the fields of IoT, cloud, and communication to provide their professionalism and expertise to let us know more about the trend of the smart IoT and the future prospects. Also, they will explain to us the latest smart solutions as well as their application and cases so we can quickly understand how to achieve industrial upgrade. Finally, I would like to thank all of the participants and the business leaders for participating in today's event. I would like to wish that all of you will benefit tremendously from today's forum, and I would like to wish you good health and prosperity. I would like to wish today's conference a great success. Thank you. Thank you very much, Secretary General Day. Next, I would like to invite Ms. Alina Lee, Executive Vice President of TAITRA, to give us her remarks. Please. Ms. Amelia Day, Secretary General of Bureau of Foreign Trade MOEA, Dr. Luo from ITRI, Mr. Aditya Rakrishma, General Manager of Siemens, Mr. Sato from Microsoft, Mr. Fu Renhe from Rockwell Automation. Our participants online and on site, good morning. I would like to thank all of you from home and abroad for joining this event, whether you're here on site or you join us online. I'd like to thank you for joining the AIoT Application Forum, which is organized by the BOFT and implemented by Taitra. So that the theme of the event is Envision Industrial Metaverse Impact and Opportunities. Due to the pandemic, because we need to have quarantine and isolation, so the way of life and the way we work has been greatly changed. So working from home has become the new normal. Even now, we are in the post pandemic era. Many companies in the Western area still maintain remote work. So the management and factories production have undergone great changes. So when we talk about AIoT, the theme of today, we need to integrate this concept into our business operation as well as the management and running of the factories. So that is the reason why, with the support of the Bureau of Foreign Trade, we organized today's forum. As we all know, under the ecosystem of the IoT, so IDC has indicated that the global output value of IoT in 2021 has reached 754.28 billion US dollars, and it will reach 1.2 trillion US dollars in 2025. Now let's look at Taiwan. According to the statistics of the National Development Council, because of the long-term deployment as well as the long-standing efforts of Taiwanese companies, Taiwan's AIoT output value in 2018 has exceeded 1 trillion NT dollars. So this is what we call one of the trillion-dollar industry in Taiwan. Every year, we have seen over 20% of growth in this area. So last year, the output value has reached 1.7 trillion NT dollars, and this year, 2022, it will exceed 2 trillion NT dollars. Secretary General Day just mentioned that in terms of Taiwan's advantage in AIoT, we have strong semiconductor and we have advanced software technologies. And over the past few years, our companies have actively promoted digital transformation. So we do have strong innovation momentum. On top of that, our industries has paid close attention to the infrastructure on IoT, AI, 5G, and IIoT. Also, our big high-tech companies have announced to increase their investment in AIoT. So, in terms of the metaverse and IoT, Taiwan does have a strong position. So, in today's AIoT forum, as mentioned by Secretary General Day, we have a strong lineup of speakers. So we have speakers from Taiwan Siemens Digital, Rockwell Automation, ITRI, Microsoft, and Quanta, and Adlink, and even Far Eastone. All these are the leaders in Taiwan's AIoT. And we hope that through this forum, we can help all of the participants here and online to better understand the application of AIoT in industrial, medical fields. Also, we can use these technologies to improve our efficiency in business management and production. Through this AIoT forum, we can bring Taiwan's AIoT ecosystem to link up with the international companies so as to establish a closer network so we can seize the next wave of industrialization. Finally, I would like to wish today's forum a great success and may you all enjoy good health and prosperity. Thank you. Thank you very much, Executive Vice President. Please remain on the stage because now we're going to invite our speakers to come up to the stage for a photo call. Now, I would like to welcome back to the stage Ms. Amelia Day, Secretary General of BOFT MOEA. Next, I would like to welcome Dr. Derek Luo, Division Director of Intelligent Machinery Technology Center of ITRI. Next, I would like to invite Mr. Aditya Rakushna, General Manager of Siemens Digital Industry Taiwan, and also Mr. Daisuke Sato from Microsoft. And next, Mr. Fu Ren Ho, New Product Introduction Manager of Rockwell Automation. So please come up to the stage. Please look at a camera. Please give us your thumbs up. So thank you. Thank you very much. Please return to your seat. Thank you. Next, we will begin our keynote speeches. Our speaker for the next session will be Dr. Derek Luo, Division Director of Intelligent Machinery Technology Center of ITRI. He will talk about revolutionizing smart factory. Industrial Metaverse creates new possibilities. Please welcome Dr. Luo.
Ms. Lee, Ms. Dai, distinguished guests, ladies and gentlemen, good morning. I'm Derek Luo. We are based in Taichung, and due to the pandemic and due to the conflict between China and the US, people are starting to look for remote solutions. And due to the 5G wave of technology, and the title of my talk is Revolutionizing Smart Factory. We know that the Facebook has changed its name to Metaverse. In principle, Metaverse is a new way of communication. In the industrial world, the technology development of Metaverse is a way to open another door for remote services. And the technology is based on, for example, head-mounted device and other technologies. And we are very optimistic about the development because for us, we are still making the content. And the question is how we can provide the service via Metaverse. So this is a picture that everybody is talking about. And some people say that it looks like you're communicating with the underworld. So people are wearing head-mounted device, looking around, and you don't know what they're looking at. However, people can actually communicate. So in the future, sometimes when you're communicating, it is not necessarily that everybody's sitting in the same room. So people can be located in different places. However, there is a virtual place where people can meet. So in the virtual place, and we can develop together, and we can share information together. A lot of people are developing similar solutions. So this is a video. You can try to find a video online. And this is a head-mounted device. And we can also see similar applications on mobile phones and other devices. And the good way of the head-mounted device is that you can free your hands. You wear the device on your head, and you can free your hands to do other things. And these devices have different computing capacity. And for smart goggles, the functions of that are becoming better and better. For example, it can monitor where your eyeballs is targeting. And the most important thing is that it accumulate different information. So there are different technologies of display or to support different functions. And of course, cybersecurity is very important, and the speed of display is very important. So for devices like this, it requires high quality internet and a very good environment to support it. And remote services is something that everybody is doing now. Now we use platforms such as Teams or some other remote service solutions to meet in the virtual world. In the space like this, people can share electronic whiteboard and to have discussions. Teams already has the protocol, and you can and draw where you are indoor. It's just in the virtual world, it's just like everybody feels like you're in a physical world. And you see that here, you don't see the um, half of the body is gone. We don't know why. And we all have this experience that when you're having remote meetings online and you're wearing a suit and people can see you on suit, but you're wearing shorts. And that's probably why we don't see half of the body. So when you're doing presentations, not only doing presentation, but you can also have some dynamic presentations. For example, you're drawing or you're having discussions. This all can be done. And for remote meetings, this is something can be done in Metaverse or AR or VR. But for industrial world, the most important thing is digital twins. And digital twins focuses on content. So what should be displayed in AR or VR? So in digital twins, what should we do? What content should we display? So we are focusing on the device, and the device can be maybe machine tool or molding machine, injection machines, and it's an equipment because in the past, when we talk about smart manufacturing, the machines has to have the capability of connecting with each other. And cybersecurity is something that we need to take care of. And the certificate of cybersecurity is also critical. And once we have that certificate, we can pull the stakeholders together to have discussions. For example, if this equipment is in Vietnam and the operator encounters some difficulties, technical difficulties, and maybe the operator can bring the maybe video communication platform, and maybe the supporting technicians are in Taiwan, and the people in Taiwan, they can put the digital twin solutions and to copy and paste on the goggle and for the people in Vietnam to operate a machine. So here you see in the machine, this is something that people are looking at the solution provided by a digital twin. And on one end, the technicians are in Taiwan and they put the solution on the screen, and the green charts is probably something regarding the quality control, something solution related to digital twins. So for us, Metaverse, we mentioned to you, this is a platform where people can present the information, and that in the industrial world, we have to put the data in so that people at both ends can resolve problems in the manufacturing process. So in the virtual world, people are standing in front of the equipment in the virtual world, and so that we can tackle the issues. And this is something that we should be prepared for. And for example, we can prepare for the future visualization and the people who are actually in the meeting. So digital twins is actually our AI system. So people and the computer, people are having the meeting together with the computer. So the people involved, not only the people are involved in a meeting, but also the digital twin system is also involved in the meeting. So all these things, these are the models drawn by the computer. You can be in different environment, and then you can look at this product from different perspectives, the functions and the design of the product, and that you can have discussions. For example, if it's a computer system, and then you can discuss whether you want to add different functions in the system. So there are different people are already developing technologies like this. We also have experts from Microsoft, the Black Belt. And this is the industrial world. We also see similar applications, for example, games or the people having virtual meetings and products to support meetings. And there are products to manage the meetings. We know exhibitions is another field, and also real estate is another field. And for example, people can now visit the property they want to buy in the virtual world, although the pictures are taken from the real property. And we also see virtual exhibitions and some, for example, machine tool shows. You can actually go into the virtual showroom and operate the machines. You can design. You can also play a program and to operate a machine, everything in the virtual world. Whether you are actually in the exhibition world, you can actually feel, you can be in the exhibition, and you can also provide the service after the products are sold. Because when you're developing the products, you definitely have a model, and you can introduce AR or a VR model. A lot of the XR tools are there already, no matter you're using the Microsoft products or from different companies or some interactive rendering. And there are already tools, programs there. And we also have a lot of business cases to resolve some manufacturing issues. For example, in the middle of Taiwan, there is a aerospace company, and they use goggles. For example, they have a lot of different equipment. So there is a table, and there is a camera connected to your goggle, and you can put the model in there and one by one and to test them one by one. So we already see auxiliary services and the products to support manufacturing the issues. And for this remote mentoring and mentor solutions are already there. And we have the support from the digital twins and the other solutions. So this is the test we are doing in the middle of Taiwan. We want to solve the issues in the manufacturing or in equipment. For example, the machine tools, we have a high volume export overseas. In the past, we had difficulties delivering our products. So we need to help our customers, because once the customers have the products at their hands, still they need our help to adjust the parameters, for example. So a lot of solutions like that are already there. For example, the HoloLens remote assist, we already see systems like that. And has allowed people to discuss different models. And this is something similar to digital twins. And for our equipment, we want to put a PLC, a CNC, or a sensor sensing the data captured by the sensors. We want to add them. Maybe some of the data need to be further calculated. For example, the thermal sensor, and once the data is there, and you not only need to have the data, but you also need to calculate to see what you have to do and to adjust the temperature, for example. And you need to have very fast data transmission speed. So for remote assist, and due to the impact of the pandemic, we have to people cannot travel, but because of the help of these technologies, we don't have to travel, and we can save time, and it's safer, and we can earn recognition, and we can extend the service from the headquarters to our customers' ends. People are talking about that if your headquarters is based in Taiwan, we need to extend our service to our customer ends. And the fastest way is to provide the service through XR or through Metaverse. And also based on the smart manufacturing technologies we had, and to provide these services through digital twins. So this will be helpful for us to transform, to upgrade ourselves. And we also know that because of the conflict, the trade conflict, and some factories, they're moving their equipment from one place to another. So this will also requires the help. And in the past, the manufacturing process requires a lot on experience. But now with AI, and we can put this experience into AI, and also through this mentor process can help to accelerate the process, because sometimes to put the controller from point A to point B, not only moving these equipment, we also need to adjust the parameters, and we need technicians to do that. And now we can do that through AR, through digital twin, through VR or XR, and we can have this digital transformation through these different solutions. We have the annotation and to mark users in different locations. We have head-mounted device, and now the issue is that there is still lack of the bridge in between. We have digital twin, we have the people, and we have the remote system, but we still need, for example, remote rendering.
So what we do is that we try to integrate the digital twins. So we know that there will be the real system, we have the data. So when these two combine, that it can be a sensor. For example, the vibration information, temperature information from the real system. Also, because of the 5G, we can have remote control, for example, control as a service. And with these real system and data, so when they are integrated, we can create the digital twin. So let me give you an example. So for example, we have the cutting mechanics simulation, PLA, and also PLM, ERP, MES, and APS, and we also have the process diagnostics. So we have the tools for equipment diagnosis. So all these integrated, they can create a digital twin, so they can help us make decisions. So when it comes to the digital twin technology, it means that there is something physical and something virtual. According to the Central Weather Bureau, well, we know that they can make more accurate prediction. This is because they have a simulation. They can predict weather in the following day or in the following week. So when the time gets closer, they can have modification because there may be some sensors catching new indicators so that the CWB can do a better job in weather prediction. So allow me to share with you an example. If we look at the equipment, for example, we can have the cutting simulation or the vibration simulation. So scheduling simulation, everything can be simulated. So when they're integrated, just like a brain of a human, we know that the reaction of this equipment. So when we input a condition, after all of these simulation and algorithms, for example, if you put into a indicator, then you know that the surface is rough or the calibration is not accurate, or within 4 degrees, maybe we know that the accuracy may be impacted. With the prediction in place, then we can make adjustments. Because of the rising temperature, we know there may be some errors, so we can adjust it back. So this is how we do in smart manufacturing. So with the help of the AI and CVS, all these technologies or like big data can help the equipment to become more predictable. And if you're selling the predictable equipment, it shows that the system is working well. If I want to sell a machine to the customer, who knows best about the machine? Of course, it's me. So if you can have a good grasp of all of the digital twins for all of the equipment, so you can provide remote services and the integrated services to help the customers to solve all of the problems they encounter. And also, we can help them increase their ability to receive more orders. So when we talk about digital twin, now digital twin can be integrated with the 3D scenario, so it can become the core technology for smart manufacturing, and also human factors and cognition can all be integrated together. So combination of digital twin and 3D scenario can help us achieve coordination. So in the metal processing industry, we have introduced the use of 5G. So some of the cutting and vibration functions can be monitored from the equipment. Also, the digital twin for our products can be observed. So we can calculate all of the parameters. So in Taichung, we have a smart manufacturing verification area. So we use AI and 5G to promote remote services because we need to have quick update of our screens. So 5G can really play a very important role. So you can see this machine. This is in Nantou, but we also showed this machine in Nangang Exhibition Hall. All these images were overlaid. So the machine is in Nantou. The observer is in Taipei. But you can see the simulation of the movement of the machine. Well, we know that machine is still in Nantou in central Taiwan, but the boundaries or everything is overlaid. So in Taipei, you can know what's happening in Nantou, even though when you're in Taipei, the data can help you to have better decision making. So this is how we can provide services remotely. So my colleague wears the HoloLens on his head. He's in Taipei, but he can still see the image of the equipment in Nantou. So our colleague in Nantou wears the glasses in Nantou, and they can have connection with the colleague in Taipei. So let me show you what I can show this video to you. Could you please play the video for me? Next, next. Here, please play the video. So this is the images that we add on top of it. So the machine is on site. So these process images were added. So we just want to discuss with the engineer how we can process. So all of the modules can be presented in front of our eyes. So people on site and also another expert in a different location can open up the information through Teams. So with Teams, with 2 laptops, we can have a dialogue to address the problem. So what we did was to paste the model of the equipment there. So please play this video. So when we render, we create a scenario. So we want to add the image, show it in front of our eyes. So this is what we see in the glasses. So we can put in more data. So we added a lot of data. So you can see this is the machine. We can move it around. So this is our model for digital twin. And this is the earlier technology. So you can see that we didn't find a good position for the equipment, but then we tried to fix it. Actually, you can see a lot of information in your glasses. As for remote rendering, a lot of times Well, sometimes you know that we can have the whole factory or the production line models. Well, but we still want to see the overall operation in a factory. So we need to have the 3D rendering for the images. As we can see here, this is a real factory in the background. And you can see it moves along. So it's actually, we have Siemens, we have Mitsubishi's equipment. So simultaneously, the controller of the equipment is linked online. So our metaverse is integrated with the equipment. And we also see the single equipment. So actually, all of the demo areas can be seen here in the whole plant. So someone's there, but how come the person's not there? Well, it's just a passenger. He's not wearing a sensor, so you cannot see his location. But in this spatial model, if it's more accurate, so even a booth there, then we can go in front of the equipment. So the equipment data can be put into this image. Next, let me give you one example. This is a real customer user case. So the computer can transfer the parameters and to find out the error distribution. So through API. So on the component parts, we have indicated the information. So through machine IoT sensing data and processing programs, we can know the coding process error distribution. So we can know whether it's a good or not a good product, what's the yield rate, so it can help us detect abnormalities. So the data of error distribution can be placed onto our 3D scenario. So our engineers can wear the goggles and they will know what's the error and what actions needs to be taken. So if he can see it, then he can resolve the problem. And he can talk to people in a different location to resolve the engineering issue. So this is what we see on site. So we can see this is a math. You can see the model is already there. So this is the view from people on a different location, and then we can identify the errors. So we have this kind of immersive interaction system. The purpose is that by using the metaverse or XR technology, we can have better prediction and digital twin and also simulation and demonstration. All these can be demonstrated in this new kind of service. Everything can be integrated. So we do not do AR or XR. We do not do 5G. But for us, we can have the digital twin system and click and mortar strategies. All these are integrated so that Taiwan's software technologies and smart manufacturing technologies can be presented in front of your eyes. We also have some remote design discussions. So in terms of the design of equipment, that's really complicated. So through the remote discussion, we can try to make improvements. So in terms of the product services or manufacturing or engineering discussion, with the help of Metaverse, we can shorten the distance and increase efficiency. So that concludes my presentation. Thank you very much. Thank you.
Thank you. Industrial metaverse in the past 12 months have developed very quickly. We know that in Taiwan, a lot of manufacturing factories are introducing industrial metaverse and to take advantage of data visualization to enhance the efficiency in the factory. And next, we're going to invite Mr. Ram Krishna General Manager of Siemens Digital Industries Taiwan.
Other guests here who are going to speak today, all the audience here in the room, and all of you out there online, good morning. If you think about the industrial metaverse, or at least the word metaverse right now, it is all over the place, right? I mean, every time you're opening a newspaper or some magazines, or when you're looking into the news, this topic is all over the place. But today, mostly, it is somehow in conjunction with social media or gaming. So these are sort of the main applications today. However, also in the industrial space, we are actually not so far away from this whole topic around industrial metaverse. And this is what I want to show you today, where already today in the industrial space, we are already there. So where we are already in the industrial metaverse, because especially in industry is where this whole topic around the metaverse and then around the industrial metaverse is going to bring a lot of help and a lot of potential for technology. This is actually going a little in the other direction. So this is actually a center of ours, the Impulse, where we are showcasing some of our latest technologies of Siemens. And this is at our factory location in Amberg in Germany, where we are producing our PLCs. And actually over the last 2 years, what we have been having is we've been having virtual tours of this Impulse Center because nobody has been able to travel. But of course, now that we are also able to travel, I would really welcome any one of you who would like to visit this center and see some of our innovations there to contact us. We do have a lot of challenges right now in daily life, right? I mean, just look around us. I mean, there are a bunch of challenges. And every day there seems to be a new challenge coming up. I mean, just take a couple of topics, right? I mean, also just take in your own daily life, personalized. I mean, over the last 2 years, just think how many personalized products you want to have. I mean, you're no longer happy just to sort of walk into a store, pick up a product, and you're good to go, right? You're no longer happy with that. You want that personalized pair of sneakers. You want that personalized car. So you want everything personalized. And this is where also, it's not magic, right? I mean, industry has to also cope with it. Every time you want a car with a different color and a different rims, industry has to cope with that. So there are different challenges. Another massive topic right now here around sustainability. And you will think to yourself, what does sustainability now have to do with the industrial metaverse? I mean, completely different directions, right? Actually, it does have something to do with it. And you will see that in a few minutes. But just talking about sustainability, and this topic is a massive topic right now in Taiwan, and especially for all our industrial customers. I mean, 1/3 of the global energy is consumed by industry, and actually a lot of carbon is emitted by industry. And especially if you look at Taiwan, right? I mean, Taiwan, we have a lot of machine builders here. And these machine builders are exporting their machines all over the world. And the question each and every one of them is currently getting is, what is your carbon footprint? What is the carbon footprint of your machine? And what are you doing to reduce that carbon footprint? Because all these companies all over the world who are purchasing these machines are investing, right? So they're investing in CapEx, and these are going to be sitting on their shop floors worldwide over the next 20 years. So that is why this is a massive topic right now in Taiwan. And it is also shown in a lot of studies, right, that the companies which are acting more sustainable are also going to be more successful going forward. So this whole topic around the ESG is massive. And also a lot of companies, right? I mean, all of us, when we're making decisions these days, we are thinking, is it going to be sustainable? Am I going to be making sure that not only the environmental aspects, but also the social and the governance aspects are taken care of? Because if not, you are going to be repenting it later, either with the press or any other topics. But also there's some other topics, right? Of course, the customers are asking, but let me give you another example. Also, these days, a lot of young talents are asking it. I mean, we all know in what sort of state currently we are in Taiwan. I mean, there's this one massive industry in Taiwan which is getting a lot of talents there. I think you all know which industry I mean. And there are a lot of other industries. All of us are trying to get young talents. And these guys or these talents, they can search in which companies they want to work in. And here's where they're also asking the right questions. What sort of decisions is your company taking? If I work for you, is your company going along this path of ESG? And that is why a lot of questions are coming around this. And that is why we need to also transform our business models. So in the first step, transforming our business models to be going on this path around sustainability, looking at topics around how are we repairing our products, how are we helping, or we as Siemens helping our customers, our machine builders, to retrofit or upgrade their products, and get this whole topic around the circular economy in place. Another topic is around the ecosystems. It is no longer going to be enough that companies are working alone. So we are going to be more and more in the future working around ecosystems. So let me give you one example for that. Siemens is currently on the path of building a sort of database, a database in which all our suppliers can enter their carbon footprint score in there. And this is going to be then a whole chain. I mean, just take, for example, the production of one PLC, right? I mean, one PLC, it is easy to calculate the carbon footprint of this PLC in that particular factory. That's easy. You calculate the amount of electricity used, the water, all fine. However, you have to also consider the whole chain below. The truck, which is bringing in the PLC in and out, or the raw materials or the plastic coming from somewhere else, also has its own carbon footprint. So you have to consider the whole chain. And that is why we are trying to work in this ecosystem now, that every supplier is able to put his carbon footprint score on this database. And this is really a dynamic thing because you keep improving your carbon footprint. So this is a topic where I say we have just one example where we have to work in ecosystems also going forward. And finally, data is important, and data is going to be important when making all those decisions going forward. And that is what we as Siemens think, that data is probably going to be the most important thing, which is connecting all these challenges you see here and a lot more challenges, and help the industry, so the machine builders or the general machining lines, be more successful. And with that, taking digitalization also to the next level. And how you ask yourself, right? I mean, how does this whole topic of sustainability now link to the topic what we are discussing today around the industrial metaverse? I mean, just taking the first step around the data which you're collecting, and also then going into the topics around a digital world and the real world. So I'll come to that in a bit, and there you also will see that. However, what we are also then trying to do is using all this data in order to create more opportunities and make our customers successful. And the concept which we are using is a so-called real world and digital world. And this is where already in the first step, right, where you just think of it, that everything, whatever you're manufacturing in the real world, first gets produced or created in the virtual world. And this is already in the first step, just think of it, saving a lot of material, and also then linked towards the topic of sustainability. But then also I will make the link in a second about how this is connected to the metaverse. Just take this chain, and this is where we say this is the concept around the digital enterprise, is what we call it, where we are connecting then the virtual worlds with the real worlds, and it is a continuous process. So it is a process where in the first step, each and every product, I will take you on an example of this in a bit, each and every product is getting realized, or in the first step, in fact, it's getting designed. So you're designing this product, then you're realizing it, and you're selling it then, of course. And then, of course, you're optimizing it. because you also need constant feedbacks on how this is taking place and how you're able to make your product better and more adaptive to what the customer needs. Let me give you one example, and let me walk you through this whole topic with one example. In Taichung, I just go to the Taichung area, right? There are a lot of machine builders. Just take one random machine builder who is maybe making bottling machines. I mean, machines for bottling equipments, right? So this machine builder is manufacturing, I mean, he's manufacturing his machines, right? And he's selling it all over the world. When he's now designing his machine, he's not starting it on a pen and on a piece of paper with a pencil or a pen. He's, of course, doing everything online, right? So he's having his CAD cams, all fine. And this is nothing new, in fact. I mean, these CAD cams, designing machines, nothing new. However, what makes it now interesting is, and here now comes a link towards the industrial metaverse, we are able to also bring the intelligence of the machine. So building really a digital twin of this machine, including the controller, all the sensors, the actors, the mechanics, all the physical aspects of it into this machine. So that means the machine is constructed, first of all, in the virtual world. And now this machine builder has got maybe a customer. So this customer could be, I don't know, a customer making bottles there. So a bottling customer who's producing these bottles or who's producing the drinks inside the bottle, and he's sitting somewhere in Europe. And this customer is also, when he's just think he's maybe making a new greenfield factory. And this factory also, he's designing everything virtually first, because he wants to make sure that in his new factory, which he's constructing, maybe somewhere in Europe, all the process flows are working exactly perfectly. Not only all the logistics are working perfectly, but also all the machines. He wants it virtually in the first step to make sure that everything is functioning properly. So there you have it, right? You're already thinking about this topic around this metaverse, or at least in the digital twin. We're not there yet at the metaverse, I come to that, but he's also having everything in the virtual world. Then he's contacting the machine builder in Taichung and saying, okay, now please send me over the digital twin of your machine so that he's able to integrate it in Europe in his virtual factory. And then he's seeing if is everything working okay. If not, he's asking for some changes. So they go back and forth between Taichung and Europe. They go back and forth, make the optimizations, and finally then it is confirmed. And already here, linking back to sustainability, you're saving so much of costs by not producing any prototypes in the real world, right? So you're saving costs there. And this is, at some point of time, this whole topic is then also coming together, where there are continuous improvements going on between the real and the virtual world there. So at some point of time later, when the machine is also then produced, the customer in Taichung sells his machines over to Europe, and then the machine is working, and a lot of data is getting created. And with all this data then, also the machine builder is able to get back this data and is also able to see, okay, what maybe I need to change for my next machine. Or the end customer in Europe is able to then also demand for some changes in his next machine, and the machine builder is able to very easily change these small things in there. So this is also enabling that in a very fast manner, these changes are able to be made and the production is working in an optimal manner. So that is why we think that this is going to be a continuous loop around this digital world and this virtual world. And this is how it looks, right? You have the digital twin of your product, of the machine, the digital twin of the production, of the greenfield production, which I spoke about. And then finally, you have your real product, so really the machine sitting in the real production line. So we are already on the path towards this so-called industrial metaverse, because we are already able to simulate the machines, all the physics, all the sensors, all the actors, everything already in there. Maybe we just miss a few small steps because we are not yet able to do it maybe in real time. And that's the idea of the metaverse, right? That you're in real time collaborating. That's the idea of the social media, right? Which also a gentleman before was showing, that in real time you're collaborating and you're working on it. But this is the vision, and this will come in the next step. So we are almost there. So we are already at a very good state in industry that we are on this path where we're having all the digital twins of the machine of the production, and this next sort of leap where you're having this collaboration online will also come in the next step. So Siemens ourselves, we are working with some leading software, or we have recently signed some agreements with some leading companies also in Taiwan in order to work on this topic, to further accelerate this topic, in order to make also our simulations more realistic, that these collaborations are happening in real time. Or another use case around this topic of industrial metaverse. So just imagine you have a production line, and at some point of time, there is a stoppage. And then you're really able to sort of go into the metaverse and go back in time and even see at that stage where it is still working properly. And they're able to exactly see what is the one thing which is happening now that the production line is maybe stopping. So this is the concept of industrial metaverse, right? In the next step. So we are on a good path. So we already have a lot of things which are probably already good enough for industry, but these innovations and these next steps will definitely continue. However, another topic which is also extremely important, and this is not a topic for tomorrow, this is a topic for today, this whole link between the shop floor, so the OT layer, and the IT layer. And this is extremely important because traditionally, I mean, a lot of us are coming from this manufacturing space, right, me included. When you're normally on the shop floor, you're not talking to the IT people, right? So on the shop floor, you say, okay, I have my machines, I have all my machines maybe even integrated, it's all fine. But this is not going to be enough in the future. You have to be connected from the OT layer to the IT layer. So just consider you have a shop floor with maybe some machine tools like we were seeing earlier. So you have a shop floor with all your field devices, your sensors, your motors, and all of these are there, right? So your motors all working and producing. About that, of course, you have your controllers, which are controlling all these systems. And then comes a topic, which is, for me personally, actually, I'm very, very excited about it. And a lot of customers of mine also are currently in Taiwan, everything around edge computing. The more we go forward, a lot of data is getting produced. All this data needs to be collected, analyzed, visualized, and then some changes needs to be made. If you do all these processes of this data in your core controllers, you're slowing down processes, and this is not helpful because going forward, you want to have more and more of such data, just like your phones, right? You have millions of apps. So you want to have some sort of device which is outside. This is not in the core process. And that is what we call as edge computing, where all these app collections or all these apps where all this data collection is happening, all the computing is happening, is on a device which is next to the core processes. And this is already reality. So we are already having this topic around edge computing with multiple apps with which we are working with our customers in order to find some topics which can help them. And then, of course, as you go up the chain, topics around the MES, nothing new, or even the cloud, which is also a topic which has been around for the last several years, where data gets sent up the cloud, analyzed, and comes down. So the one key difference between the cloud and the edge computing is that on the cloud, of course, there's probably also a small time lag, which you do not have with the edge computing, because this is taking place right next to the processes. Or also you have full control of your data here, whereas with cloud, sometimes there are some concerns. Of course, we take care of it, but there are some concerns sometimes on where this data is going, and all the way up to topics around even app development. So these are really the core technologies currently, which are helping us to go towards the path of industrial metaverse, although we are not there yet, but these are the key technologies which are helping us go there. And the topic around the digital twin, which I showed you, is already probably one of the nearest topics towards the industrial metaverse. Also, a topic like artificial intelligence is a very nice thing which we are already using also at Siemens together with selected customers to make use cases. One example, we are using it in our own factory. So the factory I just mentioned earlier, making PLCs in Germany, in Hamburg. At some point of time, we realized the bottleneck was the number of X-ray machines, because each and every PLC which comes out, or at least the PCB boards, we are doing X-rays of that to make sure that it is perfect. And at some point, and these goes through an X-ray machine. At some point of time, we realized that the bottleneck was the X-ray machine. and we could not fit in more extra machines there. So that is why we were having AI technology in order to check these PCB boards and really accelerate the number of PCB boards or the number of machines which were getting produced. So a lot of interesting topics which are reality today. However, and this is also a massive topic right now in Taiwan, the more you connect, the more there are dangers, right? So, and especially in the last few months, this is a massive topic which has to be looked at. And the answer is not, I do not connect, because we are going to be connecting a lot going forward. So really the vision is that the factory of the future, or at least maybe a shop floor of the future, there are thousands of devices, if not 100,000 of devices, which are connected, transferring data and transmitting data. So the answer is not, we're not going to connect, so we are going to connect. However, how do we do this in a manner that it is risk-free? And the whole topic around cybersecurity is met with. And this is where there needs to be a solid concept around cybersecurity, where it has to be even a multi-layered concept, which each and every company or each and every shop floor or industry has to think about on how they are handling this. So we at Siemens, we have a concept called, or it's not our concept, right? It is basically a concept called defense in depth. So this is an industry standard, which we are using not only for our products, so not only for the development of each and every product of ours, but we are also able to consult our customers about this topic. And this goes into three levels. And when you start right at the top with the plant security, and this is even just basics, right? I mean, just imagine you have a plant somewhere here, and just basic topics like security access, that not anybody can just enter into the room then, that there are some basic controls and checks around the topic. So this is already the first topic which we are maybe even able to talk to the customer. Then it goes down around the network security topic, and there we are already getting into firewalls, into VPNs, and all these IT-related topics. And here's where we're able to provide consulting services for our customers. And finally, getting into the system, so really the core of the system, also checking each and every product. So what I always tell my personal customers when I'm talking to is that you don't even have to purchase. So we're not selling anything here. I mean, we are selling also stuff, but in the first step, you don't even have to buy anything. It's free. So we're able to consult you, and each and every product from Siemens already has this basic layer around cybersecurity. So another massive topic. Also, when we go, of course, into the industrial metaverse, it is getting more and more serious. And here we also have branch-specific or vertical-specific experts here in Taiwan who are also able to sort of consult the customers, of course, in all the key verticals. So this whole chain, which I was showing you, everything from software to automation, is going to make our industries in Taiwan more sustainable. And like I say, the metaverse is something which will absolutely help industry. We are already on a good path, but maybe this final step will also make it a little more realistic and a little more faster and better for us. So resources are finite, but data is infinite, so data is important. And with that, I would like to thank all of you for your time this morning. And if there are any questions, please feel free to get in touch with us at Siemens anytime. Thanks.
Thank you, Mr. Ramakrishna, for your excellent speech. 那接下来呢，我们要进入到下一个主题哦，在制造业的数位转型。
And now we are going to the next topic. In the industrial upgrading system, we put human as the core. For people who are working at the front line, they face a lot of different tasks. For example, the production line maintenance, or at the shop floor, or industrial safety issues. How can we make the employees feel very comfortable and safe working at the shop floor? These are very critical issues. And next, we're going to invite Mr. Sato, Modern Work Global Black Belt expert at Microsoft, and he's going to share with us how do manufacturers empower employees and accelerate transformation. So we still need to adjust their presentation. But I can share with you some of the issues we might face. For example, industrial safety issues a lot of times when they were examining these equipment, sometimes the parameters are not set up. For example, some of the employees, maybe they were injured due to this setup. And these issues can be resolved through some technologies, for example, human identification or AI. So next, we're going to invite Mr. Sato, how Microsoft can help to take care of our employees, to empower our employees. Let's please welcome Mr. Sato.
Companies are pouring hundreds of millions of dollars into the vision of the metaverse.
Tech giants betting big on the metaverse.
The metaverse.
The metaverse.
What actually is the metaverse?
The metaverse.
The metaverse.
Metaverse. Metaverse. Metaverse.
If you make anything or you move anything, you create a carbon footprint. If we can simulate that infinitely in the cloud, we can make and distribute that product more effectively, efficiently, and sustainably.
There's water being used in almost every industrial process, and industries will need 100% more in the next 10 years. But with technology, we can further economic growth as well as managing our natural resources.
Digital models out of our factories have been unbelievably useful in the current environment to interrogate our supply chain, to reconfigure lines, shift patterns of production, and to do our planning and our modeling.
完全なるメタバースの世界は開発から設計ないしは試験までの全ての工程っていうものを仮想環境上で実行できます。
We are working really hard connecting all these bakeries, production lines, our logistics, transportation to provide visibility, traceability, and to be more efficient in the use of water, energy, from waste on every bakery.
Hello, everyone. I'm going to present in Mandarin. Don't worry. I'm Taiwanese now. I'm a Taiwan citizen now, so I'm going to present in Mandarin. First of all, I want to say hello to all the distinguished guests here and Tech Orange audience. Good morning. You heard the previous presentations, so you already know, you have an idea of what Metaverse is. And some presenters also mentioned about Microsoft, so I adjusted my presentation right away. So I put more business cases in my presentation. So today I'm going to give you a lot of examples, both domestically and from overseas. I'm in charge of Asia, Microsoft Asia, which includes from Singapore, Malaysia, all the way to New Zealand in the east. And I am in taking care of China, Taiwan, and Hong Kong, the Greater China area. In recent years, a lot of the focus are now on the frontline solutions for companies or frontline workers in Taiwan and Hong Kong. So for people who are working at the frontline, how can they take use of our solutions. So first of all, what is Metaverse? So first of all, today we're here. Of course, I brought some gifts with me. It looks like a serious seminar today, and I'm going to give you some Q&A and give you some gifts. And I don't want to make it look like a year-end party, so we're going to give away these presents at the end of of my presentation, so I can show you later. I brought a lot of presents with me, so I still have a lot of time. So if we have some time left after my presentation, I can give away these presents. Metaverse, we can categorize them into consumer, industrial, and enterprise metaverse. For consumers, just like we heard before, for example, social media and entertainment applications. For example, what game from Microsoft? We're not talking about gaming today, but likewise, we know this is one of the game we have, and it's used by a lot of education institutions. And also virtual shopping. We also see some of the stores, some shop owners, they already virtualize their stores, put it in the virtual world. For example, HoloLens or AR, VR goggles. If the consumers wear that goggle, they feel that they're in the shop, and they can also check the products they're interested in buying. And another metaverse is industrial metaverse. You're all very familiar with that. Due to the COVID-19, it accelerates the development of industrial metaverse. Some people feel that, okay, I don't have to go into the office, and a lot of people are working from home, so remote meetings are developing very quickly. So this is industrial metaverse. You're all very familiar with that. And for enterprise metaverse, and this is something that we want to talk about here today. So industrial metaverse and HoloLens, digital twins. We're going to show you a lot of business cases. A lot of enterprises are already doing that, especially companies overseas. And in Taiwan, some companies are already doing that, and we're still catching up. And we can show you some of the business cases from overseas. So today, this is our boss and Microsoft Taiwan. And if you visit here, you can see a lot of content regarding Metaverse. So now, please don't look at my boss. You can save that link, and you can just listen to me now. So presentation will be provided, right? Okay, you can scan the QR code and refer to the content. Now, come back to the presentation. For people who are working at the front line, a lot of people who are using the remote service, remote solutions, and many people are working in IT field. And some people, for example, if they want to make some improvements internally, and this is happening at the IT field. However, a lot of changes actually happen at the shop floor. No matter it's in Taiwan or in Hong Kong, in Asia, internationally, we hear a lot of business cases. A lot of changes happen, start from an information worker. People at the front line, so they haven't really sensed the improvement. That is actually change, because for people who work at the front line, this is the most important for a company. And we have the frontline workers in retail. So for example, if you go to a supermarket, if you go to a breakfast restaurant, and the people who are serving you, they are actually the people who are working at the front line facing the customers. If you go to, if you want to go to a restaurant, and a lot of people now first check on the comments on the internet, and some of the if it's good comments, sometimes it's most of the time it's about food, but if it's a bad comment, a lot of times it's about the service. So the people working at the front line, the quality of their service is very important, because no matter how wonderful your products are, if the service is poor, the people won't go there. And so, but we're not focusing on retail business today. We're focusing on manufacturing industry. So who are the people who work at the front line in the manufacturing industry? In Taiwan, we have some sales. However, for the industrial world, the frontline workers are the machine operators. Operators who operate SMR and some very operate machines that worth billions of NT dollars. So these are very important frontline workers. They are responsible for the quality of the products, yield rate, or inspection. So these are the people who are in charge of very important tasks. And so for these front workers, they're still working on traditional approaches, and there are very limited things they can do, although they are in charge of the most important thing in a company. For these frontline workers, they're very important, but we didn't really do a good job to help them go through the digitalization journey. So this is what happened in the past. In the past few years, we see some introduction of some, for example, OCS, Link, Sky for Business, different tools are being introduced. And as, for example, Z brand or C brand, our competitors. So these tools are used for the on the right-hand side of the screen. But what about the people working at the left-hand side of the screen? So when we are talking about the solutions at the front line, this is not only something that we can talk about in the office. We need to have the solution done in the shop floor. For example, whether there are any industrial and safety, and not only about safety, but also security. And maybe some of the internal workers, they are still not necessarily in the industrial manufacturing field. Maybe there are people who are maintaining or fixing the machines. If they need to communicate, they use personal messengers, for example, Line or WhatsApp. And if they need a application, they ask their IT department, and the IT department give them an application. And maybe you are all working in the IT department, and then we received a lot of complaints. And we interviewed the people who were working at the frontline, and they say that if we need an application, we ask the IT department. They gave us one, and if we ask 40 times, they give us 40 different applications. So it's really complicated, and we have to spend a lot of time learning how to use these applications, and then this is absolutely not efficient. And for people who are working at the front line, if they use personal chatting applications, and for example, Line or WhatsApp, and for the people who are working in the office, not at the front line, not in the factory, people who are working in the office, they're using Teams and using different platforms. And the people who are working in the factories, they're using a personal messenger application. So they won't be able to communicate with each other. So we have to put people at the same platform, so they can discuss at any time. Whenever they need to have discussions, they can be on the same platform. So we need one single platform. If that is the case, we can streamline the application, the administration process for the people at the front line, so that they can put more efforts in improving the yield rate, and the quality of the products, the quality of the workflow will be improved. So everything is closely linked to each other. So this is very important for people working at the front line. So one single platform, if we have the and then maybe what information can be put in that platform, for example, schedule or the approval information. A lot of information can be put on the platform, and if it's one single platform, education, training can be done on that platform, or even people are, can having dialogues on the same platform. Maybe the people who work in the front line, they need technical support, or they need other support. This is something that they need, a program. So they know that if they come into the office and they come into the work environment, they have one single platform. Of course, we hope that you can use Teams. And if you don't use it, that's okay. One single platform is very important. You don't have to have information scattered in different platforms. If you have one single platform, you can improve the retention rate, and the people, this is going to be beneficial for the company. And I can show you a video. So if the frontline workers, they already have their environment improved, what will happen? Please view the video.
With the tools they need to stay connected, digitize workflows, and virtually collaborate with the right experts. Joshua Van Buren is a factory operator at Northwind Traders, a manufacturing company that provides its workers with shared devices. When Joshua arrives at work, he signs into a shared device to start his day in Microsoft Teams. Teams has been configured with the tools he needs to be productive for his role. Joshua clocks in to start his shift in Teams. Shifts is integrated with Northwind Traders' workforce management and time and attendance systems, so everything is connected in one easy-to-use place. Teams also provides Joshua with easy access to all the latest information in his pinned channels. He can easily chat with coworkers here and see the tasks he's been assigned. Joshua's first task is a routine inspection for pumps in production line 1. The inspection task includes all the details for the work item, including a link to an inspection form which has a checklist to maintain equipment on the factory floor. Joshua discovers a leak on pump 7, so he indicates the failure by taking a picture of the issue and uploads it to the form. As soon as the form is submitted, an incident work order is automatically created using Power Automate to follow up on the repair. For further insight, Joshua accesses troubleshooting files and equipment manuals within Teams. He can also go into Asset Manager in Microsoft Lists to get historical context about the pump, all without ever leaving Teams. Upon discovering that a new part is needed for the repair, Joshua uses walkie-talkie in Teams to confer with his supervisor, Kaji Bell. He uses push-to-talk communications to have a quick conversation about an approval request.
We need a new part to fix pump 7.
Okay, please submit the request. I'll approve it now.
Great, sending now.
Kaji can approve the necessary permits for the new machine part using approvals in Teams. She prioritizes the work order as urgent, assigns it to an available technician, and schedules the repair. Technician Will Little receives the urgent maintenance ticket for the assigned work order. But before beginning the repair, he wants to make sure the right electrical circuits are shut down. Will uses shift-based tags to search for an expert on shift to consult with. He connects with Eric, an electrical expert based at another site. Using a RealWare hardware device with Teams integration, Will shows Eric the wiring. Using hands-free video calling and with Eric's remote assistance, Will disables the right circuits and then begins the repair. When the work order is completed, Will shares best practices for the repair in Yammer communities. Joshua sees the post just as he is about to end his shift. He posts a comment to express his gratitude for closing out the task. Before ending his day, Joshua checks shifts within Teams to view his upcoming scheduling. He can also request open shifts, time off, or swap shifts with a coworker here. Joshua then clocks out and signs out of the device. When signing out of a shared device, Intune and Azure Active Directory clear all of the company data, so it's safe to be handed off to the next operator.
Okay.
So this video just show you that with your phone, with the interface, you can complete all of your work from clocking in to scheduling to inspection, or if you have an internal app from your company, all these can be integrated. So we are hoping that we can change how you work. In the past, all of the websites are online and they are not easily operated, but now they're all integrated into the forms of app. So when you use the app, the interface can be customized to the frontline workers. So everyone can have different interface. So every box is based on the user's need or their roles, what kind of information should be presented. Maybe over here you can see the scheduling or the mission for the day, and this can be assigned by their supervisors, and the supervisor can see whether the mission has been assigned or completed, or they can see their payroll or how many days off. Everything can be integrated in this app, and this can be customized. So once you log in, automatically it will show the interface for each and every one. So we talk about that you can have communication with a single platform, you can have dialogue, you can troubleshoot, you can take photos, you can add notes, and then they can be archived. Everything can be done in a safe manner and stored, and they can have quickly feedback to the system quickly. So over here you can see if you need to change your shift, then well, I think I still have a lot of issues to share with you, so I won't reveal too many details over here. So I can save them for later. Or as I've mentioned, you can use it as a walkie-talkie. We have the function of walkie-talkie. So through the internet, so you don't need to worry about geographical area. And you can go beyond different countries, or even when you're in Taipei or in Kaohsiung, you can still use the phone to communicate, or even when you want to talk to experts abroad, you can do that as well. So this year, Microsoft has made a lot of changes because we no longer do the things by ourselves, but we work a lot of different partners. So Zebra, I think you're all familiar with that. Like in the manufacturing industry, or you need to scan a QR code, you may use their machine. And their device is very solid and rugged, and they can prevent falling. So we can integrate that into Teams. So once you click on a button, you can use your phone as a walkie-talkie. So it's just like a normal walkie-talkie for your daily use. Also, I also want to share with you something very popular. And this is our global partner, it's RealWear. So I found that in Taiwan, a lot of people are looking for this equipment. So the feature is that it's a rugged wearable device. I think all over the world does free. Well, we don't sell it, but I just want to advertise the product for them for RealWear. So anti-explosion, I think they're the only product for anti-explosion, anti-dust, and water resistant. I think this is a really good device. So on top of that, we can add Teams to the function. So we can use voice control. Let me show you a demonstration. So this is a video. Please have a look.
Creates ruggedized wearable solutions that can be used by RealWear is a partner who creates ruggedized wearable solutions that can be used by first-line workers to stay connected to other employees on remote locations. So let's take a look. Now here, I am at a manufacturing site, and I need remote support to fix the HVAC unit. Now, because Teams is integrated right in my headset, I can make a call right from this view. My programs, Teams, select item 2. Hey, Pete, how are you?
Hey, Karan, I'm good. What's up?
The L1 and L2 connections look okay to me. How about you?
Yeah, they look good to me too. Can you do me a favor and snap a photo for our records?
Perfect, I'll do that. All right, thanks, man.
Thank you.
My camera. Take photo. Select photo. Send message. Now, as you just saw, this was a real-life example of how Microsoft Teams can be integrated in a new form factor, like a RealWear headset, to provide value to our first-line workers.
好，这边我想提的
I just want to mention that with the introduction of AI, what will happen? So one case is that you can scan, you can use the glass to scan, and then automatically you can see that this step is fine, it's safe, and then it will scan. And next, we can have AI identification to make sure everything's fine, and then they can move on to the next step. So please move on to the next slide. Well, this is what we are doing, but I just want to quickly finish because I have so many presents to share with you. So I want to save 5 minutes. Well, I think that's the KPI for me today because I was told by my supervisor that it is vital for me to give out all of the presents. So we talk about HoloLens. HoloLens, as mentioned by Dr. Luo, so allow me to just jump into the topic. The Android device becomes a wearable device, and on top of Teams, we can have remote work. But HoloLens has added some really cool and dazzling MR scenarios. So please allow me to share with you a video. Please.
My name is Ari. I'm a facilities manager, and I oversee multiple sites in the Vancouver area. My job has changed a lot over the years, for the better, as new technology gives me access to real-time data like never before. And just when I thought it couldn't get any better, I now have the industrial metaverse. It gives me a clear view of all the operations across my facilities in one place. I can see the status of any asset, if workers are on schedule, and if tasks are being finished on time. I can also get an overview of all the facilities I manage. Today, there's a scheduled electrical panel maintenance at one of my buildings. When an asset is at the end of its life cycle, I've set up the system to proactively schedule a qualified vendor electrician. Kai is booked for today's job. His work order provides him with all the information he needs, from parts pickup to procedural guidance, ensuring things are successfully completed the first time round. When a sudden windstorm hits the city, the system alerts me that one of our security cameras has detected an obstruction that's gridlocking the parking lot, and 5 cars are stuck in the lot. Previously, this type of issue would have created a lot of disruption and may not have been acted on urgently enough. Now, with the industrial metaverse, the system automatically sends a work order to the vendor for the cleanup and reroutes vehicles to other parking lots. I see another alert come through from the same location that an elevator is down with an unexpected electrical issue, which needs to be immediately resolved. I approve an automatic suggestion to reschedule Kai. The system recommends him because he's the closest electrician. He's not yet experienced enough, though, to manage this type of issue alone. So a remote expert, Elle, is also scheduled to support him. She calls in via Teams and connects to Kai, who's using a HoloLens, which gives him all the relevant information right on the physical equipment. Together, they review the historical data to determine the source of the problem. Elle identifies that it's an issue with the fuses and gets Kai to launch into the appropriate holographic guidance, ensuring he can confidently complete the repair. I'm notified when the elevator is back online and see positive feedback.
好，所以呢
So by combining the RealWear or HoloLens or the walkie-talkie functions, now we can create a real design, case design for our customers. So with the introduction of digitalization, how will his day change? So the frontline worker goes to the inspection site. Then he can look at his phone. Okay, this is my assigned mission for today. So he can open his calendar and see the automatic assignment. And then he knows what kind of items for inspection today. And then he doesn't really have to go there, but he can use AI and drone, and the machine can conduct the inspection for him. Or you can see there is a crack, then the drone can use the AI to identify the issue. After identification, the image can be captured and then sent back to the database. So the people will double check whether there's a big problem. And then if there is abnormalities, then the person will have to use the phone to make it a walkie-talkie and then report a problem saying that, oh, some problems have been identified and it needs to be addressed. Otherwise, big disasters might happen. So when he does that, in the back end, the system can create a worksheet saying that there's a problem. We need immediate solution. What kind of people, equipment will be needed to address this problem? And all these can be done automatically. So when the issue is identified, and once the worksheet is established, then all these resources will be sent out automatically. So, and then we need remote collaboration. If this person found that, not me, I cannot solve the problem by myself. I need someone abroad. We need experts. In the past, we have to wait for people to come, but now we can call the experts abroad. Then probably you will need to call someone overseas. Then we use RealWear, or you can use HoloLens. By wearing the device, we can see the image. The image can be sent back to the engineer in the back end. So the engineers remotely can see immediately what's really happening on site. Well, probably it's a 3D simulation, so the engineer can draw. You can click, you can do this and that by using the arrows or the picture, and then we can complete the inspection. It's not done there. We found a lot of frontline workers, well, they think that they have done, but sometimes if it's kept in a paper form, well, things may be lost, but now we can use the tablet form, so you can sign it on the surface. Seriously, because we have the pen, so I really enjoy using the Surface Pen. So you can have the signature and you have the e-file saved. So everything will be documented and archived and everything will be stored. So this is how we design that when a frontline worker conducts the inspection work after digitalization, this is how his work can be changed. So this is a real use case. We gave you a demonstration. So if things happen, then we can have a situation room on the left. You can put on a HoloLens, then people in the situation room remotely can see what's happening on site. They can see the simulation, and people on site can wear the anti-explosion or dust or water resistance device to conduct the repair, and experts remotely can provide experts. So every supervisor or experts can see remotely. I still need to advertise. We can use the Surface Hub. So it's very suitable for our supervisors to use that. So the supervisor can monitor remotely. So this is what we say, the mixed metaverse, but now we haven't used AI. I think this is still the enterprise metaverse, but if we use AI and automatic identification or automation, so we can create the industrial metaverse. So by the end of last year in an exhibition, that was how we demonstrated. We had a real use case, so we reported to Mayor of Kaohsiung. So allow me to share with you the video. So please unmute the video. So when things happen, we need to get the data. We can see the model, so we can have an immediate simulation and find out the problem. So if problems happen, then we can capture the photos immediately by wearing the RealWear or HoloLens. Then people in the back end can see the complete situation on site. They can give orders and command. So why do we need to see what's happening, right? We all know what happened in Kaohsiung, right? So that was the demonstration we gave last year. And finally, I would like to share with you a video. This is just what happened last week. Coca-Cola used our MR to help the company. So when issues happen, people in the situation room can wear their glasses to see all of the machines in their factories. All of the data can be demonstrated. Let me share with you this video. Please turn up the volume, please.
H's bottling facility in Adlink, Austria. This immersive digital twin helps gain visibility across production lines and puts all of the different elements into one single view So if you give me a second here to start the app, let me dive in. So if you can see here, we have a full view of the A3 line represented from Edistal, Austria. And if I click on each of these individual elements, you can actually see real-time IoT sensor data coming off of them, which is really helpful for the people on the lines because it runs 24/7, so maintenance staff gets real-time insights. But if I actually take a couple steps back, what's really exciting is I can give you a better view, calling in an AI assistant to run a potential data simulation.
Single view improves the ability to make data-driven decisions. Here we can see the current overall output of energy, water, and CO2.
So this AI assistant was created using Azure Bot Framework's neural text-to-speech, as well as various performance capturing tools. Not only is she bringing real-time insights, but she's taking this structured and unstructured data, she's telling it to us in real time and can give us actions to take on top of those insights. So, assistant, show alerts.
You have an alert on one of the elements. Showing it now. Here is a comparison of CO2 emissions with energy usage. In this view, we see the correlation between energy consumption, the operating state of the machines, and CO2 emissions. Lowering temperature and pressure settings could reduce energy consumption by 9%.
So now that we have these data-driven recommendations, we can go back to the various teams and stakeholders and meet with them either in Mesh or Teams and discuss these data-driven recommendations and try to optimize operations even further. So back to you, Gabby.
Thank you, Morgan. So we
Okay.
Microsoft has the manufacturer cloud. If you're interested, then feel free to contact Microsoft and we can give you some explanation. We can help you accelerate transformation so that you can enjoy the benefits of industrial metaverse. So finally, do we still have time? I have some time to give out the presents. So I think this is a very good product. So allow me to share it with you. So this is the universal voltage transformer. And also we have the small pack. We have 5 each. So I have some questions for you. The first question, what are the 3 main aspects of Microsoft's Metaverse? Please raise your hand. Okay, let me do it again. So you can exchange your business card with our colleague. So pick one person. 1, 2, 3. Pick one. Industrial what? Industrial Metaverse. Very good. What do you want? Thank you. What is the second kind of metaverse? Gentleman wearing a blue mask. Yeah, enterprise metaverse. Very good. So we need to make sure that we can see people raising their hand. What's the third one? On the left, please. The lady. No, what kind of metaverse? The third one. No, wrong answer. Wrong answer, but people try to help. Yeah. Yeah, the consumer metaverse. That's the third one. Well, I think people are really generous when we pick a lucky draw or when we have a pop quiz. Then I know. I think it's good that. And then we're going to give you Surface Hub. No, actually, I'm just making a joke. Okay, the second question. No, question 4. We talk about a hardware from our partners. What are they? What are the hardware equipment? Just give us one example. Zebra, okay, good, very good, Zebra. Good. Yeah, I think people love the voltage transformer, so that's really good. Anything else? I talk about partners. So partners. Okay, so one more for you. Yeah, if you buy a product, then definitely we'll give you more. Do we still have more gifts? Okay, one more. Like 1, 2, 3. Okay, real world, very good. Well, you're all really listening attentively. Thank you so much. The questions are not too hard. I think we have, oh, we still have some, give it one more equipment, right? Yeah, in the supervisor's office, what equipment can be put there? Walkie-talkie. No, I mean what's inside the supervisor's office. I mentioned the name of the partner. What is that? Oh, very good. What other questions can I have? This is a very difficult question. So the next question. Okay, time is up. So the final question. All these platforms will have to exist on one single platform. So we recommend that after the meeting, what is the platform you have to use? So who's going to buy our product? Okay, once again, 1, 2, 3. Teams, right? Have you purchased Teams? All right, that's all for today. Thank you so much. Thank you very much.
Thank you, Mr. Sato. This morning, we hear a lot of business cases, and a lot of them are related to MR and AR. In the process of introducing these technologies, it's actually a challenge when you're introducing these technologies into your own factory. The next speaker is Mr. Furen Ho, new product introduction manager of Rockwell Automation. He's going to share with us applying AR technology in real-world factory scenarios. Hello, everyone. I'm Furen Ho from Rockwell. I want to thank the previous speaker to make everybody very excited. So today I'm going to share with you how we apply AR technologies in real-world factory scenarios. So before that, let's please look back what happened in the smart factory field in the past 10 years. We started from Industrial 4.0, and people were talking about Internet of Machines, talking about automations, and how we can apply the protocols, how we can find the different protocols. And once we have all the information, all the data collected, and then the next step is how we can present this data, and we see a lot of different applications of dashboard. And so what people were focusing on is that what information can be shown, for example, the utilization rate of the machines and how people at the remote end can see how the machine is working, what is the efficiency, what are the pain points, and what are the barriers of our production lines. And so these are we see a lot of different dashboard, efficiency dashboard or power dashboard, and also visualization. And once you have the visualization technology,
technologies, what is the next step? We already have the AI, and people started to think that how we can streamline the production line and how can we have sustainable production, because we already have the data, and we have the data maybe at the cloud, and we started to see cloud solutions.
And it includes a lot of the know-how from the people who work at the shop floor. It's not that you provide an AI tool and you know what the pain points in the factory. For example, a lot of petrochemical factories, even if you provide the data, and if you don't have the concept, you don't really know what to do at the shop floor, even if you have the data. And the people are still the key. How you can integrate AR. So we heard the presentations from Microsoft and from Siemens. And if you want to realize these technologies in real factories, especially for AR, a lot of AR technologies are applied in gaming field or in the consuming products. But if we go back to the factory, the most important thing in a factory is that we have to visualize what you see is what you get, because in a factory, industrial safety is very important. So we have to put the right information at the right place and to the right people. So in the following 20 minutes, I'm going to share with you how can we find the best solutions in the circulation. We want to thank, we heard the hardware, HoloLens, and other hardwares, and we still need to collaborate with softwares. And this is the AR integration or AR tools. But when you're introducing AR technologies, in the past 2 or 3 years, we've been promoting technologies, how you can integrate these technologies. The clients, they don't know what they're going to do. They said that, okay, I see AR and very advanced technologies, and you can integrate the real world and the digital world. But if you ask the client what they want to do, they don't really have a clear idea, and they just let their imagination flow, and just like what we saw in the videos. But in the shop floor, you have to consider a lot of things such as safety. And so we heard from previous speakers talked about the remote collaborations. So if we need some support from the shop floor, and we need the support from remote, and how do we do? And also how we also have the process sorting and the factory inspection and homing. So there are different aspects, and AR is mature enough to assist these different fields. And the solutions can be done. Of course, there are challenges. However, there will be need for consultants to come in and to provide their know-how. So first of all, let's look at the remote collaboration. You can't see it very clearly, so just listen to me. So expert support. So in what kind of scenarios is needed? And for example, for equipment suppliers, and once the equipment is ready, maybe the equipment is produced in Taiwan and then sold to different parts of the world. And the machine is very good, and the ones is shipped to overseas. How can we maintain the machine, and how do we manage? And if the machine is having some issues, and how do we fix it? And all the experts are here in Taiwan, and how do we make the clients understand how they can maintain their equipment? So this is something that we need to do when there is an issue at the moment of when the issue is happening, and what can we do? And buy AR solutions. And that is one thing. Another thing is that the people who are on fixing the equipment on site, maybe something is broken, and at the time when the equipment is not working, and if we do not have the a very fluent flow, and if we do not have the material, we don't have the spare parts available. And just imagine that you are an engineer on site. What you need the most is that you need somebody and to tell you what to do, what to where to see, what to do, what you can try. And for the engineer who are on site, the most terrible thing is that he doesn't have anything to support him. So what we can do is through SLAM technology, simultaneously location and map. So we combine the map and the location. it was originally used in unmanned vehicle, and once the vehicle is driving through, you can recognize what are the dangerous areas, and so the ambient environment can be recognized and to see whether there are any dangers being identified, and this technology can be applied in factory. And for example, the equipment is not working, and we do not have the time to establish any models. We need expert to give me the right information at the right time. So we have a quick scan. For example, we already see what's going on, and we have the environment set up ready, and we know what is working, what is not working. And now we have the space annotation technology. And once we have the annotation, and for the people who are the technicians who are helping you remotely, they can see the screen and to provide you. And so people on site can operate, and the people who are working remotely, they can also operate, and that they can share information using the real world device, and that they can transmit and divide the images or information. So the advantage of that is that it's a plug and play, no more development required. And so the engineer can collaborate with the assistant from working remotely. So this is something that we see. And the equipment suppliers, they sold the products overseas, and when the equipment is not working, and the engineer working on site, they need help. And this is where the technology can be applied. Data is being collected, and this data can be used for training materials for the future. And so here we have a video, and just to show you what the flow will be like.
画面就是远端的人看到的画面。
So this is a screen seen by the people who are working remotely.
那你看到那标注都是我们做。
So you can see the annotation being pasted real time.
远端的人就可以立刻做文字。
So the remote assistant can take notes.
文件分享，我可以。
Document sharing, whether it's PDF or different documents. You can use the goggle, zoom in, zoom out to view these documents. On the right-hand side, you have real-time translation.
在拍照啊或录影。
Photo taking, video taking.
好，那接下来讲到下一个。
Okay, the next application scenario is equipment maintenance. So this is different because this is more like a fixed factories, and every day we send somebody to inspect the factory, and so this inspector needs to take notes of what's going on in the factory, and if there is a problem, he or she needs to report. So this is in a fixed location, for example, in a factory. And the pain point here is that for experienced inspectors we have less and less talents like that. And maybe the inspector is not an expert in all kinds of different equipments, maybe the pipelines or equipments. And how do the inspectors know where to go, what to see, and it's easy for them to miss anything. If there is any problems, and then maybe he or she becomes panic, and then maybe some of the flows SOP will be forgotten. So if there is a space modeling being established, and this inspector can know what he or she needs to do when he is in a specific space, and this will reduce the load for these inspectors, and he doesn't have to memorize everything, what to see when he's in certain space, what to do. So first of all, I have to scan the space or to establish the model, and there are different ways to establish the model, maybe using the target approach. These technologies are very matured, and it really depends on the application scenarios. What kind of target is most suitable? For example, areas target or image target. There are different technologies, all mature technologies. And for example, area target and the equipments are put in place in a fixed place. They are not being moved around, and we scan the space, and then we can put the functions, adding the functions one by one. And for model target, we can focus on the equipment and to integrate different information. And for image target, we can put a lot of layers of pictures together. And so different applications in a company or in a factory, you won't be able to adding so many things all together, integrate everything together. So you need an AR support team behind. So wherever we go, and we can have the support being notified that what I should do and what I should look. So for this new flow, you can use that for training newcomers. And so for newcomers, even without too much of a training, he or she can inspect the factories and to confirm a lot of different the equipment they need to see. So the model is established, and then being edited. So this is another example how AR technology can be applied in factories. So these are mature technologies. The question is when can be used and what kind of technology is more suitable for the actual factory. The next one is process sorting. So what do we mean by that? We talked a lot about AR technology. The one thing very important is people, human beings. People are smart. They know what to do, when to do it, and if the water is hot, well, I'm going to touch it. The fire is hot, I'm not going to touch it. It's not that a fancy AI application telling you that, okay, the water is hot, don't touch it. And when you realize it or taking the note from AR, and you're already being burned. So the information integration is it's all about the flow. For example, when we're trying to troubleshoot where does the information come from, whether it's from equipment, from IT system, or after inspection, these information can be fed back to the database. So all these processes need to be sorted. And for AR development, and also for people, we know that when we're introducing some of the solutions, the client said that, oh, okay, why do we need a goggle? Because these inspections are the inspections we're doing on a daily basis. Why do we need a goggle and to sort all these things out? This is something we're already doing. But the thing is that we have to combine these three different aspects: people and the system and the equipment. And after a lot of business cases, actually the role we play is not only that we tell you what to do, because AR is using another maybe IT technologies or CAD, or maybe the applications are used by the gaming field. And so the most important thing is that you have to understand the flow. So Rockwell, we can integrate a total solution and to provide the right information and to the right people at the right time. It's not that we try to just give you a goggle, you just use the goggle. No, it's not like that. Our solution is that we have a comprehensive interaction and it can connect to your system, combined with your platform. And the platform can be maintained by the client themselves because maybe some of the models it needs to be adjusted or the flow needs to be adjusted, and sometimes you need to go back to the original developers. But our advantage is that these platforms can be maintained by the client themselves. And this is an example I'm going to share with you. This is a pumping station. There are fewer people as staff in the pumping station. In the pumping station, in this case, there are only 4 people. They take shift. And they inspect the pumping station by turns, and they have to look at a lot of different equipments. So we review the equipments they need to check. So this is the area these inspectors need to see. And then in the pumping station, there are a lot of equipments, probably 14 different equipments, and the surrounding equipments outside in pumping, and maybe every gate and so these inspectors need to go to see all these equipments, and everyone covers 12 hours of a shift. And if the pumping motor is not working, and this inspector needs to call out for help, and there are things that they won't be able to complete the tasks, or there are things that they missed out and then they need to complete the work afterwards. So traditional approach is that now the inspectors before they had a lot they used a pencil and paper, and now they already have a tablets to help them, but the flow is still using the traditional approach. And so for the inspectors, they are very experienced. They know what to do. And so for the tablets, maybe the tablets are not helping them. Sometimes the inspectors, especially for experienced inspectors, they don't need the tablets to tell them what to do. And in the process, sometimes the inspectors have to go up and down, climbing the ladders, and holding a tablet is not necessarily convenient for them. And once they have recorded everything, they need to they need to do the management work. If there is something that is not working, they make a phone call, and maybe they fix the problem afterwards. So for these, to address these traditional pain points, we introduced the AR goggle. So this, we know for wearable devices, they're supposed to support you. It's not that you stare at the device at all time, because we don't want to confuse people. It's only when people do not know what to do, they use AR goggle to facilitate them. So we don't want the goggle to interrupt them for doing what they're very familiar with. So afterwards, the data can be uploaded, and then data can be further analyzed. And we help these inspectors and to sort out all the tasks they need to do. So, and in the process, we know what their pain points are. For example, they have to inspect a lot of different equipments which are scattered in different locations, or information cannot be transmitted, or there are newcomers who are not familiar with the pumping station. Maybe he or she was transferred from another pumping station, and before they go take their task, they didn't have the time to go through comprehensive training.
So you can log in, you need to know what kind of items that you should sign up. So this is the design process. So we have 3 major directions. The first one is for inspection through AR. You can see the equipment and our virtual image. They're put together so they can show. So whenever you go there, you stop, you can see the items for inspection, and you can follow steps. And it's not complicated in terms of inspection. You need to see whether the out appearance is clean or whether there's leakage. It's not complicated, but we don't want to miss any step. The second one is system operation. So just like how you use the tablet, at what time you need to report on, and if it check, then the important thing is that when the equipment is fine, no movement is required. You just take a photo, upload as an evidence. So then if there's an event, you record a time, you need to make sure that some actions are done. Then in the future follow-up, then you can use the photos to see the situation on the shop floor. So if there's problem, then you can have more actions. So this is the second step. And the third one is troubleshooting. If there is failure on site, where can I find people to help? Most of the time, they need to outsource, so the people on site don't know what to do. So if it's pouring, then the motor is stuck, it's not working, and I don't think there's any way for you to find any way on site, so you can use remote collaboration. So all three areas will be included. Let me show you some videos. So we can use the annotation on the space, so you can give some explanations. So please play the video for me. Whether the bolts are loose or the lines are moving, you can see what's presented in the goggle to see whether the outside is clean. Confirmed. Bolts are at the right position. The oil is at a normal level. No leakage from the oil pipeline. Inspection complete. So the content is not complicated, but they need to check whether every step is taken. So if you're familiar with the steps, then you can do it. If you're not familiar, then you can follow the steps. So AR plays a supplementary role. So the inspector doesn't really follow the steps, but they just do what they're familiar with, and then they just need to check and confirm. So what we do is that we need to identify the steps so we can help the inspector. And the second one is about the records. If you need to keep some records to see whether the equipment is working properly, or you need to report. So allow me to skip some of the places. So the first part is I enter the pump station. You can choose the steps and the items. So you can take photos and it's done. So we have a system. You need to take a photo. Without taking a photo, you cannot move on to the next step. So if there's a problem, then in the second part of the video, you can see it will tell you there's a problem. So after the problem is identified, then before ending the task, you will need to take a video or take a voicemail and then send back the information. So in the backend, it's very easy for you to manage. So if everything's okay, you just need to take a photo. If there's a problem, you need to take a video, or you need to take some voicemails. Then if I need to generate a table, then it's easy for me to find back where the problem is. So please play the video. Start. So all of the steps. Check the outside appearance clean, whether there's oil and water leakage, with the bolts have moved. Enter. So regarding the detail, you'll see what have been checked. So if it's good, then just continue. So there are so many items. Correct. So overall, these major items are correct. Then we will add a photo. Take a photo. Next, to check the clutch. The outside is clean. The bolts are protected. The lines are moved. So the outside is not cleaned. Continue. Error. Continue. Add a video. The outside is not clean. Please pay attention. Stop video recording. Add notes. The outside is not cleaned properly. Please pay attention. Next. Complete. So over here, you know which are correct and which are not. So during the process, I have sent information back to the backend. So it will generate a table. So when we do the inspection, we can see the problem. So in this process, we have combed through all the processes. So we start with the annotation. Well, on a tablet, it's just a device. They will check the device independently. But we find that this is such a big equipment. Well, actually, you cannot check all of the equipment individually. Then, so in this process, maybe we encounter that 2 or 3 equipment are on the same route. Or in the next round, what we do is that we use the process to go through all of the equipment. The third one is that we simulate the situation. If there is a problem, how can we ask for help? Please play the video. Check cooling water pipeline. There seems to be a leakage. Understood. So this person has called the expert remotely. You might need to check the valve next to it. Take a step back. On the right, there are 2 meters. Please look at the numbers. Higher. So I show number 0. Can you see number 0 and 1? Yes. Please check the values, whether the values of these 2 meters are correct. What are the values? Okay, I can see the values. So for the meter marked number 1, both are fine. So please confirm. Now don't move. Please look at the check. Please see whether the area marked with X, whether it is hot. Is it hot? If everything's fine, please move up the handle marked with a check. Move it up. Open it. So this video shows the calling for help on a shop floor. So it's not that we're establishing a model. So by scanning the equipment, I can complete the simulation. Then you can map, you can save everything. So then you can now know how to pull out which map for remote assistance. So this is just a simple example for us to troubleshoot. So when we go through all of the process, how can we introduce AR? We have taken a few actions. The first one is status monitoring. How can we help the people at a shop floor? Maybe without SCADA or without HMR, how can we make sure that they know the real-time information? How can they send back the information? And also the route guidance, like where to go, then you can scan, we can provide guidance. And also the SOP demo, I can send out documents. And final one is remote collaboration. So these are the main areas that we can use AR to help us integrate all these different aspects. And for Rockwell, we provide the MR. This is mixed reality. So we combine AR and also the inspection procedure together. Everything is integrated. So our role is not just to provide a solution, we also provide consultancy to our customers. So we will talk about the spatial planning, hardware, also the source of the data, all the way to the function confirmation. We can do the POC. So we have worked with one customer when doing the POC for the equipment. They say, if I send an inspector, I will spend like 30 or 50,000 NT dollars. That's actually much cheaper than the money we have to pay for Rockwell. But after implementation, they generate more new ideas. So we continue to develop the system for our customer. So we know that our AR and MR is that to do the right thing, to provide the right information to the right people. So everything, all of the information can be combined. So thank you very much. Thank you for your sharing. So in this morning, we have seen the diverse application for industrial metaverse. So whether it's the introduction of MR or the digital twin for the simulation of a production line of a factory. All these foundation can be done through the application of data. So in the afternoon, we will talk more about data application and how AI, 5G, or the innovation can help our company. So in the afternoon, we will invite people from Quanta, also Adlink, and Far Eastone, and they will share with us their experiences. So we will conclude the morning session. In the afternoon, we will start at 1:30. So we'll see you in the afternoon. Thank you. Hello， 各位 Our participants on site and online, good afternoon. I'm today's MC Yunjie. Welcome back to the 2022 AIoT Application Forum. In the morning, we had detailed discussion about industrial metaverse as well as its application and how it's going to be implemented in different factories and production lines. So amid this trend, data is the key. Data also drives the development of AI and 5G. So in the afternoon, we will focus more on the data-driven transformation. What can the companies and factories do to establish their new business models and achieve different innovation? So before we begin the afternoon session, I would like to invite our speakers to come up to the stage for a photo call. I would like to invite Dr. Ted Zhang, CTO of Quanta Computer, please. Next, I would like to welcome Mr. Ethan Chen, Senior Manager of Edge Computing Platform BU at Adlink Technology. So please look at the camera. Please give us your thumbs up. Thank you. Please return to your seat. In the afternoon, we have invited 3 different representatives from different companies, from Quanta, Adlink, and also Far Eastone. So during the process of digital transformation, we see different innovation and different optimization for procedures. So our existing work, maybe further expand it. So I would like to welcome back to the stage Dr. Ted Zhang, CTO of Quanta Computer, to talk about when digital healthcare meets Metaverse. I would like to give the floor to Dr. Zhang. Thank you. Good afternoon. So the organizer wanted me to talk about digital healthcare meets Metaverse. So this is my topic. Interestingly, this is the most famous movie. When we talk about metaverse or digital twin or other technologies like VR or AR glasses, we know that in the area of aviation, they have started using these technologies long time ago. So they have very mature technologies. So from this perspective, I would like to talk about data. So let's look at data, how Metaverse can be used in the vertical industry, especially in the field of medicine. Interestingly, you can see there's an airplane, we have cars. It seems that man and the fighter jet can forge a twin. So together, they can complete a mission. But long time ago, when we first started working on the digital model, we just follow Newton's physical law to find the governing equation. That was before the advent of AI. So before AI, airplanes could fly. That was because of the science and technology first to understand the dynamics. You can see that now. What we need to know is that how can we understand a physical system to make it into a model? There are two types. The first one is the analytic method. We use analysis to get the math model. And then you can have the mathematical model. And then you can have real-time simulation, which is close to the real situation. Why is simulation important? Well, before the person is ready, without simulation, you cannot put a person in a battlefield. So a simulated scenario is created for the person to do something, to operate the equipment in a simulated environment. And why is simulation important? Because without simulation, we may be the guinea pigs. If you go see a doctor, you get medicine. 3 days later, the doctor will see your situation and give you a different medicine. To some extent, we're actually just like a guinea pig. If we are not performing well, the doctor would make some adjustment. But in the area of AI, what matters is that where is your digital twin for your body? Can we simulate the situation in a metaverse? So whether in terms of precision medicine, we hope that it can be implemented in the simulated environment so that we can predict the future. Boeing 777 started the concept of digital twin. In the past, when we sat in the large airplanes, we need to have simulation, and that was really expensive. But we thought that maybe we could have a digital simulation. We can reduce the costs in the real environment. So that would be moved to the metaverse. So back in 1989 until now, digital twin has existed for a long time. These ideas are actually not completely new. It's more like passing down from generation to generation, just like AI. So now what we see is the translation between two worlds, or how can we see a different world from our world, and how can you connect the two worlds? We need to find out what's the upper layer of data, and then you can find an area for data application. So the verse is not just data. We need different verticals, but it's not just for entertainment. There are more applications. So in terms of the data evolution, it can be used for consumers or for application. You can use it in the factories or in the airplanes. But behind it, if the background's changed, then the data can have different applications. So what I focus more is X. How can you have transformation to move from one world to another? So if it is done better in the other world, then we can send it back to our own world. So you need to have simulation. Then when you return from virtual to reality, well, you have to take everything into consideration. So all these 4 spheres will interact with each other. When you go see a doctor and you have so much data, can you really find out the digital simulation for your organ? Every person has different organs and different status of aging. Then we can have precise surgery and medication for the need of the surgery. So we have collected a lot of biological data. You can create a model based on the data, and you can create a digital twin. On this digital twin, you can have prediction, prevention, and also other personalized medical care. All these are revolving the digital twin, but now we use a different language to describe it. So Quanta, when we started working with MIT, when we work on the IoT, so when New York Times interviewed our experts asking what is big data, so they first talk about big data. They collect the data of a patient, they collect the DG data and then print it out, and then they go back to ask the journalist, can you read the data? No, of course not. So we need machine learning to read the data. That was in 2006 or 7, we started doing this. So IoT has a feature. It's not just about technology, it's about internet. How can you connect or how can you collect precise, accurate data so that you can create a model, and model can help you make prediction about the status of the patient. So starting from there, about 2016 or 17, when I gave a speech in Australia, we started to combine AI and IoT because you collect data. What's the purpose? You want to create value out of the data. It's not just that you're just collecting data to do something. IoT is Internet of Things. It's not things of Internet. But because in Taiwan we are so strong in hardware, so we will start from the hardware. So we don't pay so much attention to the software, but it's a pity that actually we're not paying enough attention to data, and we didn't pay enough attention to the algorithms on the data. So AIoT now has become the mainstream because now more and more people are studying AIoT. We have seen more collaboration. 3 years ago, I also published a paper on IEEE talking about the application of AIoT. So I think it's all about artificial intelligence out of things. So from here, you can see if you want to create a digital twin for a person, in the past, we used linear pathway, but actually, people are complicated and even chaotic. It's non-linear. So we know that neural network is just like that. So we need human to share their wisdom, to turn the wisdom into artificial intelligence. So it's a process. So it's a process of mapping. So if the raw data and your data, so metadata, so you find the word meta exists. So in a meta world, in a metaverse, that's the venue for metaverse. But I think all these are continuous. It does not just happen out of the blue. So we have a lot of medical wearable devices trying to see that how we can collect more data in people's normal lives so we can provide real-time support. So that would be one way for us to go forward. We know that a lot of people want to go to see the doctor. They want to cure the disease, and sometimes the disease is cured, so we cannot have more tracking. But the reason why we're wearing these devices that we want to track the data, we want to collect the data. So at MIT or MGH, we have a lot of students using these kind of devices. The purpose is to create a complete system. So we can do it for the heart, we can do it for other organs. Human bodies is just like a universe. Every organ is a part of the metaverse. Every digital twin is part of the metaverse. So you can see that when it becomes even more digital, every body has its own digital twin. So based on this digital twin, in the future, doctors and hospitals can provide even more accurate and precise medical services. As for real-time data streaming application like Akamai, what they do is that how to distribute the content in a secure environment and how to show the data to you real time. The key is that, for example, during the surgery or when doctors learn how to perform surgery, so the doctors will know the information needed. So the system will provide the necessary information. So if you know, like if you cut here, whether the blood would squirt out. So this is something that can be predicted. So what we do is that how to convert the real world data into a model so that it can be used for future medicine. So you do have the physical world, but how can you digitalize the physical world? How to extract the metadata, how to create a digital twin, how to visualize the data. So XR, AR is just one layer for visualization, and then you create a metaverse. Then can you have good simulation so that in a digital sphere, you can have simulation which will be in line with the real situation. So it's like two different metaverses. I cannot just use my real world for trial and error because I may fail. But if I put it in a digitalized metaverse for simulation, so the simulated results, if it's good, then I can bring it back to the real world. So one successful case was that the Siamese twins separation in Brazil. Why is it successful? Because a metaverse was created to simulate all of the processes for the surgery. So during the process, they gain very satisfying results, and then they go back to the real world to operate, so it can be done very quickly.
最成功的。So that was the most successful example. Are there going to be other examples? A lot of work has been done, but it's not as simple as a goggle. There are a lot of academic development behind it. So we know that at the mobile era, everybody was talking about APP applications, but now we're talking about IoT. And what's behind IoT is that how the data can be collected and create metadata. And the main purpose of metadata is to create AI, artificial intelligence, AI modeling. And after you have that, what you hope to have is that to create more applications in a metaverse environment. So everything is linked together. And for me personally, we know that a lot of things can be linked to that. It's an ecosystem. It's not only one single thing. It's a ecosystem, a comprehensive ecosystem. And how do you create an ecosystem and with enough technical elements to satisfy different needs? Everything is critical. For us, and in terms of the medical field, we believe that health is a process. The objective is to achieve happiness, and so we take quokka, that's the cutest animal in the world, and we take it as a name. And the cloud is a combustion engine to make everything work. So from this perspective, if we want to look at medical behaviors for one person, and if we want to have precision medicine, we want to do that in the cloud at any time, anywhere. You need a lot of IoT wearable or portable devices. You create data,
And afterwards, you need to train this data. You find the metaverse, which will require human intelligence. You artificialize human intelligence and to make it the base for digitalization. There will be a lot of digital neural network which create a model, and you can have a lot of influence, whether it's remote or not. You can create a lot of things based on that. But these are the data that come afterwards. But the original data comes from DNA, and so with that DNA, which is born with us, and we can further develop that. So the way we see is that we take our body as the source of the data, and IoT is a very important tool to collect data. 5G is also very important. So cloud computing, machine learning, they are all critical. And how do we connect these items to hospital? You know that we're very good at making devices, and we're very good at cloud technology. And in the cloud, what we do is big data analytics, so that you have AI and that you have to provide it to edge, and there will be a lot of data transaction happen. You have to secure data transaction. And you will realize that some technologies in fintech will be applied. For example, blockchain, so that you can complete the model. In the process, you'll find a lot of technologies that need to be applied. So there are a lot of elements. So you have to optimize by using green and energy. And people might ask, why don't you put 5G? Because 6G is already happening. So I just put a G here. When I delivered a talk in another university, and people ask us what our strategies are. So basically, this is the direction we're going. So we use a hardware platform to support AI, and this is a low code or a no code environment to help the doctor turn data into AI. And afterwards, you still need to extend the service. And so what we need to create is the link between hospitals and how we can link homes to hospitals. And probably not many people know that the open text for the National Concert Hall and National Theater Hall, that was actually developed by our company. And we also won the award and only have the software. And because this is a virtual world, so we take the metaverse approach. So you can see here, so you see data, and this is where we work on AI. And we also have the connection. We want to connect hospitals to hospitals, and we want to connect hospitals to home. And there are a lot of medical AIs, IoTs. And so this is how we build a AIoT ecosystem in the medical field. So we work on cloud, but not only focusing on hardware. We also work on software. And we know a lot of big hospitals, National Taiwan University hospitals, or other big medical centers are already creating that models. And we also see some of the amazing results being exhibited. And you know that our focus is not only on technology. Technology is just a vehicle to bring us to the future. This is just a vehicle. What we care the most is how we change the social behavior and the human behavior. How do we create the business model? And when the world is changed from high tech to high touch and zero touch, what role does technology play to enable the new environment? And there are a few things when in the process. There are things that we need to do together with our partners. Number one is mindset, and the second one is the past behaviors. If you want to catch up, what do you need to do to upscale, or how do you expand your scale?
from your existing scale. So we help everyone to take on the metaverse journey. So we have an AI factory. It will be convenient for the hospitals to change from a patient center to cloud center, and so that they can develop AI. And this is what we've been doing. And this is the hardest part for people to understand, because we take the overall AI process to take it. We take it as an AI factory. Of course, telemedicine is also very popular, and speed is an issue. There are a lot of different types of mobility, and maybe you are in a car. The speed when you're in a car. What kind of networking strategy you want to take? You want to choose from when you're in a car. In the hospital, there are different departments, different expertise. Whether you can just put all the data. And then maybe one patient go to a hospital to see appointments where the department, maybe he wants to see, maybe wants to visit eye doctor, but that hospital doesn't have the facility. However, it can utilize the virtual information, virtual resources. So this, in a way, is an initial metaverse, because we've developed the hardware and software, and that there are different types. And you can also see from here, the reason why we want to create it is because once we have it, we can further develop metaverse. And if we have people here and the people have conversation, this will eventually become metaverse. So you would take your home to be a virtual ward. There are a lot of old people, and in Europe, this is what happened. And the hospital just take every individual's home as a virtual ward. And this is what we did in the Netherlands. And the oldest patient is 95-year-old patient. So you don't really have to teach the patient. The patient can learn how to use it by themselves. So, and some of the patients are farmers, and they injured when they're planting their crops. So this is the remote scenario, and you can connect the daycare center. So two systems being done at the same time. We did pretty good there. So Quanta, we did that in 1988. We did a lot of things that may not be widely known. We turned the ideas into real things. And when I just joined Quanta, and we have quite a lot of progress since I joined in. And at the time, we didn't have a Chromebook, and so we made one, and we provided the computer to remote areas in Africa you also know that we made a lot of wearable devices, and we worked together with MIT and for autonomous cars, and we also did a lot of things, for example, helping elderlies, and we also helped to create the ticket selling systems. And not many people know that we also work on robot arm, and we're number 2 and number 3 in terms of the collaborative robot arms. So so this is the time when we want to advertise for our own company. So Quanta, we are the global innovator. Together with MIT, we have the human-centric computing, cloud computing, and AI computational technologies. We worked a lot of projects. And my boss just texted me. My boss is not in Taiwan, so I can say whatever I want. So basically, we work together with MIT, with on different projects and across a lot of different disciplines, such as the projects in hospitals. In Taiwan, we have two centers. One is in Yangming, Jiaoda, and we have an AI research center. And in the south, we also have another research center in the south. And we also have a computing center with the National Taiwan University, and this is also a system from Quanta. In Taiwan, we already have 40 hospitals are working on our own platform. We have a lot of partners around the world. And because I am also the co-chair of digital working group of APAC. Now, what we're working on is around Asia Pacific countries, how we can share the best practice and to promote these best practices into countries where they have the digital gap. So in July, we had a digital health forum, and experts around the world were discussing on these issues together in July this year. And this is something really interesting. Of course, there are a lot of projects related to AI, and for 3.0, and our direction is Metaverse. So this is my last slide. I don't know whether my time is up. This is something that we're working on. Metaverse is and the technologies that started quite early on, and then now it has really accelerated its development. Thank you.
Thank you very much, Dr. Zhang. Dr. Zhang is also the president of Quanta Research Academy. So it has studied a lot of important technologies like AI, 5G, and cloud application. So the Quanta Research Academy has provided a lot of R&D in these fields. So amid these changes, we know that in the area of medicine, now we see a lot of technological applications, but we do want to have the human touch in medicine. So speaking of the future, we still want to provide services focused on people. And the second one is we see a lot of automation applications used in factories or production lines. So when we talk about future, the factories in the future, we understand that there will be a lot of AMR robots responsible for moving the goods, or they can be linked to the elevator. So without pushing the buttons ourselves, they can move the goods to different levels. So what are the applications behind the scene? Now, we would like to invite Mr. Ethan Chen, Senior Manager of Edge Computing Platform BU at Adlink Technology. Please welcome Mr. Ethan Chen. Good afternoon. I'm Ethan. I'm responsible for Edge Computing Platform BU of Adlink. So today I will talk about envisioning AMR in the era of AIoT. So allow me to give you some advertisement of my company, Adlink. We are established in 1995. We're just neighbors. We are in Taoyuan. So Adlink started the company with measurement, and then we tapped into the market of edge computing back in 2018. So we became Compass of Intelligence Company of the Year. So we have 30% of the revenue invested in R&D. So in terms of the deployment, actually we are not as diverse as Quanta, but we have bases in Shanghai and also other parts in China. And we have the R&D center around the world. And also in San Jose, in Silicon Valley, we have our own R&D centers. So we started from control to industrial computers about 4 or 5 years ago to respond to the trend of AIoT. We move on to the next area for transformation. That is the area of AI. We're the first NVIDIA's partner. So from the bottom, we help NVIDIA create the embedded GPU, and upwards, we created AI machine vision. We had the AI platforms and also ROS robotics controllers and now GPU servers. All these are our services. So we can do a 5G GPU. So to respond to the trend of the AIoT, these are the services under different BUs based on our own capabilities. We have such kind of deployment. Over the last 20 years of experience, so we have seen the new applications of AI from robots, self-driving cars, and 5G. And we have tried to make contributions to the open source community. So today I will talk about the application in robotics. So the ROS community is also an area where Adlink has continued to contribute. So robotic controller is called ROS Cube here in Adlink. ROS means robotic iOS, robotic operating system. So that's the framework used for developing robots because we are very interested and we have continued to make contributions to the areas of robots. So now we can use ROS the term as our model name. So other companies cannot use the name ROS in their products. So as for ROS Cube, in terms of the use of robots, we have software and hardware integration. So whether for autonomous driving or network connection, we can use our ROS Cube system. So what is ROS? ROS, it's robotic OS. So it's not really an OS, it's built upon our framework. So, and the ADR research in 2024, over half of the robots will use ROS framework. So from ROS 1 all the way until to ROS 2. So we started ROS 1 in 2010. So after 10 years, 7 different versions. Now we're in ROS 2. So ROS 2 was started in 2017. So in 2022, we have a new version of ROS. So with constant evolution, you can see we have released a lot of different functional packages. So around the world, a lot of companies, they have tried to show the prototypes of the robots. So based on the features or the capabilities of the companies, we try to optimize or they can develop the functional packages for their robots. So some of the robots have their unique features or special functions. They can be included in this area. So why we have such great difference between ROS 1 and ROS 2? So you can see we started ROS 1 back in 2010. So we only had an idea. But so for ROS 1, it focused on the standalone robots in terms of the visual handling, motor control. After 10 years of development, now we are at the stage of ROS 2. So we have a new idea that is the swarm robots. So we use the word swarm. That is just like a fleet for the vehicles. So among robots, they can communicate with each other. It's like P2P communication. So you know that they have PBS. So we have the peer-to-peer communication among the swarm robots. And we can give them missions so the swarms can complete the mission all together. So this is how the swarm robots work together. Moving on, my final page for advertising my company Adlink. So we have worked so hard in the field of ROS for so many years. We also, in Kyoto, we had a ROSCON held in Kyoto. That was the annual convention for ROS. So we just presented our Neuron SDK that was developed by our company over the last 5 years. We want to show more libraries for more apps and management tools for our customers so that they can quickly operate and manage the robots. So in the annual conference last year, we presented the SDK as a free software. So we remove all of the limits and we want to open SDK to all of the users. So if you use the SDK to your hardware, that can run as well. The purpose is that we want to continue to contribute to the field of ROS so that more people can use the ROS operating system. I think this is a win-win strategy, but still we have the paid version for our operating system. So let's go back to the topic. We'll talk about AMR, autonomous mobile robot. So we can nail it down to other areas. We can talk about different robots. So we can say that AMR is the vehicle that can be mobile and go to different places. For example, we can have the selfless driving cars, selfless trucks or buses, or food delivery services with robots. So today I will just focus on the indoor AMR. All the other AMRs can be used in different areas. They adopt similar technologies, but what you need is more precise and safer and higher efficient applications, especially in terms of the vehicles. It has to be much safer. So you need to have secure MCs to ensure that all the data is correct. But if we talk about the indoor AMR, well, they will not pose a threat to human lives that easily. So we don't need such fast computing abilities. So they have different functions. But in terms of the logic for software design, I think actually these applications are quite similar. So if we talk about AMR, you can see these AGVs. In the past, they were called AGV, Automated Guided Vehicle. So you can see the track on the ground or the lines or a QR code. The AGV can be guided to a certain route. So it's just a stupid machine. It can only travel along the designated route to perform its task. But now it has been so advanced. If we have the AMR, we don't need to plan the route for the AMR. It can have sensing ambition. It can avoid the objects and move around. So this is the advanced and thriving version. So to create an AMR, there are several key components. The first one is you need to have the vision, that is the camera, and also the LiDAR and robot sensors. Also, you need to have the motor control and also AMR, the brain. So that is what we are working on. That is the robotic controller. This is a platform for software and hardware integration. So robot controller is key. So in the AMR market, it's booming. It's really diverse. So in 2020, the market size said that by 2026, the market value will reach 1 billion. So the CAGR is extremely high, like almost 16%. So you can see the diverse applications. That is because we know that a selfless or a manless vehicles can be applied in so many different areas. So you can have the industrial cleaning robots or robotic arms and all these kind of different applications. So over the past few years around the world, we have seen some POC landing. And for example, over here, you can see these partners in Asia. In Taiwan, we have the POC for our robots. And in the APAC region, we have worked with some logistics companies for their logistic AMR, and we have the AMR in factories and AMR in shopping malls. They can provide services. And in China and Japan, we work with some system to do the autonomous delivery robots. So that's the last mile. So maybe Uber Eats will use this kind of services to send the food 1 block away, and this little robot will deliver your food to you. And in US or in Europe, we have done some interesting experiments. For example, we have the autonomous golf car and also the delivery robot and also disinfection robot in response to the pandemic. So in the shopping mall, when people are gone, then they can have the disinfection of the mall. So this is not MMR, but I think this is really interesting. So this is the driverless racing cars. I think over the past few years, we do see a very interesting experiment for the racing cars, because racing cars can go fast, over 200 kilometers per hour. So for one controller to control the sensor from data, so that is AIoT. I think it's not enough because it moves so fast. So we need also a server on the vehicle so that the large amounts of data can be calculated and analyzed so that we can respond to the need at such a high speed. So we can make decisions very quickly. Now let's go back to the technology. Today I will only talk about 2 technologies so that you will stay awake. The first one is that the first thing for AMR to do is the slam. What is slam? Let's say I knock you down and I throw you into a different environment. When you wake up, what's the first thing you do? who am I? Where am I? Where am I going? So it's the same for robots. Before performing the robots, it needs to know who I am, what's my number, what I should do. So the purpose of SLAM is to tell the robots where it is. So by means of the cameras and lidars attached to the robots, so throughout the process moving, it can sense the environment to create a map. And then after the map is created, and then we can move on to the next step. That is to plan the route, navigation, and then they can perform the task. So SLAM is definitely the most important thing for the robot to do once it is started. So you may think, well, this is so far away from you. It is not relevant, but actually this is very relevant. This is my iRobot at home. This is my newly purchased iRobot. So before performing the task, this is what the iRobot is doing, SLAM. That is creating a map for my home. So the kitchen or the trash can, everything's there. So, and it goes to the living room. Well, this is the map. So this is what we call the SLAM. This is the first step for the robot. So even the iRobot at your home can do that.
SLAM, just like I said, the ROS package, it has the open source. And there are some professional companies are making the SLAM business software, and it provides the it can provide a really high precision with the camera. And the reason why we highlight this is because LiDAR is really expensive. Maybe a camera, 10,000 NT dollars will be really, really good. But for LiDARs, it can be as expensive as millions of NT dollars. So LiDAR is something really, really expensive. And that is why Tesla Model 3, and it canceled LiDAR. And with the prerequisite that Tesla is very confident about its own AI model, so it can solve the autonomous driving issues with its own technology. So here, this is the Intel Real Sense 3D camera. And with this camera, it can have precise SLAM. So if you use 2D LiDAR and compared to this, the precision can be 11 centimeters, but the precision can go as precise as 3.3 centimeters. It really depends on the AMR, where it is used, and whether you need that level of precision. And there may be some robots, and depending on the context, you do need a really high precision. Maybe you're in a very narrow space, and because of the location precision is not very good. And it's, for example, you're loading goods on the truck, and if you cannot really reach that level of precision, maybe your goods will fall off because of imbalanced. According to the AHAI for MAI SDK kit by Intel, Goten is already in the functional block. So if you use the Intel platform and the Edge Insight SDK, you can use free Coden inside. The next technology is Panasync, TimeSync. It's different from TSN network. So on the AMR, you can achieve time synchronization. Why is it important? Number one, multiple camera time synchronization. Sometimes you can use as many as 10 cameras, maybe a small MNR. It can have 3 or 4 cameras. And for these cameras, needs to catch the same picture at the same time. And normally 1 second, 30 pictures, and even more for higher level robots. And so how do you make sure that these cameras can take photos at the same time? If it's not synchronized, a lot of serious problems will occur. For example, the unmanned racing car, because it's as fast as 200 kilometers per hour. Every second, it moves more than 60 meters. So 0.1 second, there will be a few meters difference. And because there may be an error of 0.1 second, and there will be meters of distance differences, and people might get hurt. And sometimes when you're looking at things, of course, your left eye and your right eye look at the things at the same time. And this is what we want to achieve for cameras. And sometimes for different types of sensors, how do we blend them together? And this is a LiDAR cameras. And for LiDAR, it's has the mini wave 360-degree scan, and it can scan the environment. So for your cameras, it depends on the depth information provided by LiDAR to enhance the precision, the accuracy. So LiDAR needs to be in the same direction with the camera, and the camera takes picture at the time. So on that direction, the sensor triggered on that direction is the right information. So you have the visual information because your data has to be accurate. If you have the right data, and you can get the right information after the computing process. So this is a simple example, camera plus LiDAR, and after sensor fusion, you can identify objects in a precise way. There are a lot of environmental elements will affect the results. For example, the person who's wearing the color of the clothes is very similar to the background, which will result in not ideal results, and maybe the rim will not be clear because of the color of the clothes worn by the person in front of the camera. So the shape identification will be affected, and with the support from LiDAR with this depth information, the result can be a lot better. Next, I would like to share with you the actual case, and this is IdealWorks, and this is a very important partner of ours. This is an AMR company under BMW. So this AMR is powered by BMW, and I downloaded this picture from their official website, and you can see a ADM logo on it. So if it covers more and make AD-Link to D-Link, then I won't be able to give the presentation here. So it has more than 230,000 parts, and so AMR. The challenge for AI is that this AMR needs to be have the capability to identify obstacles, because there are a lot of AMRs moving around at the same time. You need to change your route, and when you are docking or moving the goods around, materials around, they are moving in a narrow space. So these AMRs need to learn by itself. So together with NVIDIA, we help the client to build robots like this. And so controller, and together with NVIDIA SDK. So this is the SDK specially developed for this AMR. So the client developed this upstream applications, and SLAM is the most important thing. You have to know, the robots have to know where they are, and so safety groups, how they can identify obstacles. I have a very simple video to share with you.
Reshaping the way we work. In logistics, there is a plethora of robotic solutions to support staff with almost any task there is. At IdealWorks, we enable the logistics of the future by providing the most flexible and scalable robotics ecosystem. Our autonomous mobile robot, IW is an integral part and distinctly stands out from other options. Using SLAM technology, the IW Hub navigates autonomously and is able to both detect and avoid obstacles.
So you see that when the robots are lifting, You have to make
them to serve an abundance of use cases and to respond flexibly.
OK， 那影片呢？
You can find this video on YouTube if you're interested, and you can find the video. I don't have time, so we cut the video. So on top of the client like that, we also work together with AOU, and there are different kinds of robots, for example, robot arms, and working together with AMR. And we use our experience and to provide solutions for AUO. And we also understand that in Taiwan, a lot of companies are small and medium companies. Not every company has the luxury, has the resources as AUO. And some companies said that they are making their own controller, but they want to buy AMR. What should I do? So we work together with Foxconn and establish a company called Far Robot. So this company is making robots, and to a company that produce AMR robots, we can help our clients, and we can fine-tune the robots on site so that the robots can execute the automation tasks within the factory. So I still want to focus on that we contribute to the field of rods. So for 3 years in a row, we worked together with the Taoyuan city government and to organize a rods summer school. So a lot of outstanding engineers join us. Originally, we were planning to have physical courses, but now because of the pandemic, we have the virtual courses. We also invite experts from Intel, NVIDIA, and Quoten, and they have their own expertise for AMR, and that they have the video clips on the website. If you're interested, you can have a look. And this year, the registration has ended, but next year you still have the opportunity to join the online course. Lastly, the products and the technologies we want to offer. The platform required by robots in terms of hardware, it is just industrial computer. But the reason why we want to stress that we're working on robotic controller, it's because our contribution in this field, when we're promoting this products, this is a product combining software and hardware. And it has the ROS framework and also the TPS technology between machines. This we also have this DTS technology. And a product like this will help you develop your own robots or AMR, will accelerate your development process. This is my last slide. What Adlink is offering here in the robotic field, it crosses the automation in a factory or unmanned vehicle. These are all our domains covering software, hardware, and we have a lot of eco-partners. We can provide the applications you need. Thank you. Thank you, Mr. Chen, for your excellent presentation.
So he has talked about a lot of different technologies like SLAM or AMR or Kutan. All the information can be heard in Edge Open. It's a podcast by Adlink. So there is a lot of detailed explanation in a podcast. So if you're interested, you can listen to it on Apple or on Spotify. So talking about smart factories and also the technological development, I think the core is the establishment of the dedicated 5G network. In Taiwan, we have a lot of important operators for telecommunications. They can play a very important role throughout the process. And next, we would like to invite Mr. James Lee, Vice President of Enterprise and Carrier Business Unit for Eastone Telecommunications, and he will talk about 5G empowers a sustainable digital-driven future. Please welcome Mr. James Lee. Good afternoon. I think we have very good arrangement for today's agenda. Dr. Zhang talked about Quanta's efforts in the beginning for healthcare, and also Mr. Ethan Chen talk about the second stage. And these two companies are our important partners. So you talk about products or services, and we also need the system integration to deliver the products to the customers. So I think what we can do is to provide a one-stop service or like a whole package. So I'm not really advertising my company. I think we all know Far Eastone and also Far Eastern Group. Under the Far Eastern Group, we have 10 different verticals. So we have done digital transformation. Usually, the biggest problem we encounter or difficulty in the beginning is that, well, what we do is we provide the IT services. So all these factories, they are the OT. So the language of IT and OT are completely different. We basically speak very different languages, and it's very difficult for us to communicate. But because we have so many different verticals under the group, so we can help both sides to co-create. So under the group, Far Eastern Group, under 10 different verticals, we can try to communicate among ourselves, and then we can deliver the services to our customers. From 2021, I think over the past 1 year and a half, we have seen that the 5G application services has continued to develop, for example, in the field of smart cities, smart manufacturing, transportation, healthcare, education, finance, construction, culture, safety and disaster prevention, and retail, everything. We can have hundreds of applications, but every system integration operator, they cannot do everything. Take Far Eastone, for example. We focus on our own 6 core technologies. The first one is the network, 5G network. Well, that is our core competence. And the second one is that we talk about the big data, AI, IoT, and AI, and also the hybrid cloud. Quanta is our important partner for our self-owned cloud. And also, whether it's about AI or IoT, we also see the problem of cybersecurity. In under Far Eastone, we have our own cybersecurity team. We want to manage all of the security issues. So based on these core competences, we try to help our customers to achieve green digital transformation. So please allow me to share with you some of the applications. I will share with you some of the cases. I will talk about the green building management and also smart medicine. Dr. Zhang talked about medicine. So I'll talk about the implementation. And Adlink has done a very good job in smart manufacturing. And I think smart manufacturing is also a very important application for the 5G dedicated network. So in terms of transportation in the smart cities, that is also a very important area. So moving on, allow me to share with you some cases. We help Taoyuan city government to build a whole city interconnected street light system. In Taoyuan, there are 160,000 streetlights. Every of them is connected to the internet. So we can say this is the largest single street lamp system. By so doing, we can save 15% of power consumption. Everybody is now talking about ESG and cutting carbon emissions. So 15% of power consumption, it is equivalent to 22,500 metric tons of CO2 equivalent, which is about 58 Da'an Forest Park. That is how much carbon can be absorbed. So this project has also won the Lighting Annual Award. So from what we see around Taiwan, even in the big cities, I think only 10 or 20% of the devices are connected to the internet. So in terms of the operation of the street lights, usually most of them are still very traditional. So when the people or the head of the township sees that the light is out, they have to make a phone call, and then the city government will send someone later to conduct the inspection and repair. But now in Taiwan City, it's a different story because every street light is connected to the internet. So we know immediately whether the light is on or not. And also, we have collected 2 years of data. So by AI analytics, we can predict a specific street light may fail at a certain period of time. So even before that, we can have preventive maintenance for the street lights. So this is how we improve the safety at nighttime. So the next step for the street light is that I know will be a very important infrastructure for the city. So we can have the 5G small cells, and by using big data, we can have the car flow analysis. We can install a lot of cameras for image recognition, and we can have the air quality detector to ensure the air quality. So we can have more applications. Let me share with you another example that's also in Taoyuan. We do see the tourism industry is recovering if you go abroad. When you come back, when you go to the Taoyuan International Airport, if you look down during the daytime, you can see a lot of reflections like the mirrors. Taoyuan City is the city that has the largest number of ponds. So ponds in Taoyuan can help with the water resource management. So in Taoyuan, in terms of the water management, Taoyuan is playing a leading role. So for Far Eastone, through our own IoT, we help them establish the smart IoT monitoring system for sewage. So all of the water resource, like for example, when there's precipitation before the rain, you need to know whether the pond can store how much water. So during the rain, like before or during or after the rain, you can manage the water level. So if accidents happen, then you can respond and you need to evacuate the people. So because of our efforts in building a system for Taoyuan City, we can cut down the use of human resource by 40%. So this is really a large percentage. Another example is telemedicine. We live in the urban areas, so maybe you think that telemedicine is not relevant to you. Let me give one example. When you live in a city, maybe within 6 minutes of walk, there'll be a clinic around a corner. This is the situation in the cities. But if you go to the rural areas or even the tribes in the mountains, it's a completely different world. Based on the survey, in the indigenous tribes, 60% of the people living in the tribes, because of the distance, they prefer not to go to see a doctor. And because they don't see a doctor when the illness is minor, it may become exacerbated. So if the illness is serious, so from home to the hospital and then back, it may take them 6 hours of time for commuting. So when we deploy the infrastructure for telemedicine, what we wanted to do is to solve the lack of medical resources in the rural area. So this is from a social and charity perspective because we believe that medicine, education, and telecommunications are human rights. We want to ensure everybody can enjoy such equal rights. So that's why we are talking about we use the internet to replace the roads so that medical services can be extended to every community and households. In addition to the rural areas, we hope that we can reach out to the communities and families. We know that Taiwan is an aging society 10 years later. This system will serve our own needs, like in the urban areas. For the old apartments, there are no elevators. So the people, senior citizens living alone on a fourth or fifth floor without elevators, actually, these are the rural areas in the big cities. So last year, our telemedicine application received the award from the Golden Graphic Awards. We are also a non-medical institution to receive such an award. So when we talk about the telemedicine, I talk about the difference between IT and OT. So in this system, we are certified by HIPAA of the United States. I think this is the highest level of certification in medical services. On top of the telemedicine, we hope that we can put it under the scenario of the ambulance application. We want to seize the golden moments for emergency services. So in terms of the first responders' efforts, they can use the VR or the camera to send the information to the doctors in the ER immediately. So ER doctors, even they're at a distance, they can provide assistance to the EMT personnel so we can improve our rescue capability so that we can reduce the time for rescue. This service has been applied in National Cheng Kung University and Kaohsiung Hospital. So now in Taipei, we're also doing POC. And this is our application of 5G. In addition to the telemedicine in smart city, we also can use it for different purpose. So this is the New Year party. This is the application for entertainment. So we use the free perspective to provide live streaming. So we can have multiple connections from different places. We talk about hundreds of fans joining the performance virtually. In fact, starting from last year, we help Honghai, Foxconn. Well, during their annual year-end party, well, due to the pandemic, they make it into an online party. So through our system, we organize the year-end party for them. So they have 37 locations around the world. So over 100,000 people join the platform online. So through 5G, so all of the signals can be sent to different corners of the world. On top of that, through AIoT and digital twins, we have established the smart energy management and monitoring system to build a low carbon building. So it includes energy saving, environmental control, safety control, logistics, and also operation. So this case is in Taipei City. In Taipei, there are 2 large public housing being under construction. Now we are helping them to establish these smart building platforms.
At Far Eastone, starting from 2019, we have helped a lot of enterprises to establish designated network from 4G to 5G to provide a wireless connection. And just like Adlink just mentioned, AGV and AMR, it is the applications that combines 5G services. A lot of factories need to change the production line very quickly. So 5G will enable them to deploy their production line very quickly. And because of that, the information becomes transparent and information can be shared. And it can reduce human resources and to reduce the cost of deploying these networks. And this is another case. This is the case of this year. In August this year, we worked together with Marlow Automation Corporation and MOXA. We established the automation housing, and that it has AGV, AMR, and automated picking facility. So these functions are enabled because of 5G technology. So we work together with companies such as Adlink to accomplish that. Starting from 2019, we've been working together with MediaTek. And we know that MediaTek chips, they have been working very hard to catch up. And now we are one of the international major players. And starting from 2019, 3.5 giga, we see one production line, one after another, starting from 3.1 giga to millimeter wave, and everything is being constructed. So it greatly helps the efficiency of the production line. In the past, they used simulator. It's slow and costly. And now with the real 5G network, we system to test the scheduling, production scheduling. And this is a project last year. We worked together with Delta and Microsoft. And this is probably the first real 5G smart factory. We know that especially during the pandemic era, now it's getting better, of course. It's possible that when the pandemic is severe, it's possible that the factory might be locked down. So the factories are working towards way how to reduce human resources, how it can become highly automated, how it can be connected to networks. A lot of equipment at the time cannot be imported. So we also help them to do MR. And because of our help, the per capita output increased 70%. And the full production line output, initially, it can be 75%. And within 1 year, the investment can get its return. And next, very quickly, I would share with you that in our group, there are different fields we work on. And I'll play the video for your reference. 5G drives the transformation of manufacturing industry with the three characters of low latency, high bandwidth, and wide connectivity. It provides production management and factory management. So 5G large bandwidth accelerates AR and MR applications, which can assist in material preparation in production line. And the AI learning and AOI optical recognition system transmits images in real time through 5G and can perform automatic defect detection and to improve inspection speed and quality. With the 5G high stability wireless network features and AI intelligence diagnosis, monitoring equipment operations, and can predict maintenance schedules and prevent sudden equipment failures. Transport fleet management, integrate human and vehicle information, master the physical state and the behaviors of the drivers. AI image recognition is applied in access control and industry safety management, which can detect personal safety equipment of personnel and management access control. Combined with electronic phase, human noise detection, it can automatically determine whether there is an intruder. For large-scale inspections, drones transmit abnormal images through 5G, and the information platform aggregates key information of production line, and it can help managers to grasp operation status. Far Eastone, under the 5G proprietary network architecture, combined with the big players, can accelerate towards smart manufacturing. So this last slide is an advertisement. In the past few years, internally, starting 6 or 7 years ago, we already performed the digital transformation. And now, within our company, we sell what we use. We export our core capabilities to our customers and to assist them to perform digital transformation. Through our own confidence, we do hope that we can help our clients and to catch on the journey of digital and the green transformation. And for Quanta, it's a very important partner of ours. And we do hope that the price can be more competitive. Okay, Mr. Lee, please stay on stage. May I please invite other speakers in this session onto the stage for group photos. Dr. Ted Chang from Quanta and Mr. Chen. So please look at the cameras in front of you and give us a thumb up. One more. Thank you. We thank 3 speakers, and also we thank all the audience. Thank you very much for joining us. We'll see you next year. Thank you.